Okay, so can you hear me? Okay, thank you for coming. Thank you for everybody who's online, and I assume you've had two already fantastic days. My name is Donald Kossmann. I'm the director of Microsoft Research in Redmond, which is the biggest lab, and I will not give you a big Microsoft spiel here or what we're working on. I'm going to give a talk kind of that I literally hacked together yesterday evening on some of the thoughts that I have on the future of programming. And the talk is entitled, If Then Else Considered Harmful, and I don't know, who of you has programmed today an if then else statement? Nobody? I'm pretty sure you use if then else or some kind of branching, you've used that. So I just want to dive in and get going. And so this is, hopefully you see or you understand this program. This is bubble sort. When I started computer science, to study computer science, like 500 years ago, this is what in the first semester that was taught. And essentially when you want to sort, it's essentially bubble sort or whatever, quick sort, whatever you do, you compare two elements, and if they're out of order, you bring them into the order. And that's how we mostly program sorting today. And I will argue, of course, that this is wrong, or maybe in future we'll do something else. But essentially, if then else is fundamental to all of our programming exercises that we do. And here's the kind of the new form or the new way how you could think about sorting, where you essentially don't have an if-then-else statement, where you don't compare things, but instead of comparing things, you compute things. You don't compare is A smaller than B and then you swap. You compute is where A should go to. And that is really the important thing. So instead of having an if-then-else statement, you essentially have that with a multiplication. And actually there is kind of a way to reprogram every if-then-else statement with a multiplication, but here this is really a bigger fundamental change on how to program. And I'll just describe this algorithm, and of course it is inspired from this machine learning revolution, or the AI, or whatever you want to call it, that is sweeping through the planet. So just to give you the algorithm, let's say you have this sequence 13, 5, 7, and so on, and essentially what you want to do is you want to learn a function, f here, that predicts the position of every element of the sequence. And if you are somehow in the machine learning space, actually this function is pretty trivial. It's called the CDF, the cumulative data frequency, and it's kind of a function that you will find in every, or training this, you will find in every library, R, Python, you will find it all over the place. So it's actually pretty trivial, and if you look at it and you do it, it actually does sorting, right? And it does it, and that's the important thing, without an if-then-else statement, without comparing. Actually, you need to compare because these machine learning is never perfect, but the main task here is really multiplication and not comparison. So what this talk is about is, why is this happening? Yeah, everything okay, or do I need? No, okay. So why is this happening? And there are several trends. Of course, the big trend that I'm mentioning here and that is based on is the machine learning revolution, or the AI revolution, which makes huge investments into this kind of computation that we need here. But there are also some other trends, and those are the trends that I want to briefly mention here, but I really want to go into the third trend, the software engineering trend, or what is typically called software 2.0. So one is the hardware. So if then else is actually really, really bad on modern hardware, because what does it do? It branches, and it results in a huge amount of mispredictions of the processor, which essentially translates into poor performance because you have to fetch data from cache, right? Into the cache from main memory, and that's kind of, main memory is the new disk. It's like going to the Jupiter and fetching data so that you can compute it. So you really don't want to do that. And when you have branching, you have to do that much more often. It's much more difficult to parallelize things. So those are the hardware trends. And so it's actually, these days, it's more efficient to do a multiplication than to do a branching. Of course, if you would have asked kind of 50 years ago the inventors of computing, they would say, oh, multiplication is a super complex algorithm. And if then else, you just do a little bit of comparison. But because of the modern hardware and the way it is laid out, actually now multiplication becomes much cheaper. And there are also, of course, accelerators, GPUs that do it very well. The second trend that I will also not talk much about is security. Everybody here has heard of Spectre and Meltdown, I hope. Yeah? Okay, a small nod here. What happens in Spectre and Meltdown is it exploits exactly this structure of a program where you do mispredictions or where you do predictions and there's some fetching, some pre-fetching, and that results in vulnerabilities. So really you don't want to have if then else, if at all possible, because they're a security threat. They're a side channel threat if you think about enclaves and this. What I will go at is the third point, which the term software 2.0, have people heard about that? Kapati, and I want to give my twist to it. Of course, software 2.0 was coined for self-driving cars, but what I really want to go here at, and I want to say, this is for everyday hacking programming, not for the high-end self-driving cars. This is really for the mundane programming tasks. So that's what I will focus on, and a little bit the story here is ML kind of dominates today for perceptual tasks and all things that we would call in the kind of industry programming the impossible. So if there's no traditional way to program something, then you will throw AI at it, right? And this is kind of like, oh, there's nothing else we can do. And actually, it has been fantastic actually to solving these problems, like perceptual tasks, self-driving cars, and it talked about that. And what I will argue is that we will go more and more into mundane programming tasks. And what I will want to focus on is programming policies. Programming is something where you have to make decisions. And a lot of mundane programming tasks are decision-making. And that's where you typically have an if-then-else statement, right? If the sun shines today, I'm going to go hiking. If it rains, I'm going to go into the sauna, right? That's a typical branching if-then-else statement. And if we want to automate, we are confronted with these situations all over the place. And of course, in systems, I build systems, platforms, I work the cloud. You have tons of these places, but I really want to go at the application level and give a small example. So assume you want to sell ice cream. And you're an ice cream vendor. You want to go to a school, and you want to kind of, in the break, at 10 a.m. or the Tsununi break or whatever it's called here, you want to sell ice cream. And essentially the problem that you have is, well, is it worth to go and sell ice cream? Because if it rains, there's probably not much consumption of ice cream, so it's not worth it to get up. And if the sun shines, how much ice cream should I order and bring with me and sell it? And I want to get that right, because if I order too much ice cream, then that ice cream is going to go to waste because it's hot and it's just going to melt. And if I order not enough ice cream, then I'm going to miss an opportunity to make revenue. And this is a typical scenario where you would want to kind of learn from experience, and you want to kind of every day kind of adjust. You want to make a decision every day on how much ice cream to order. And let's say you have this curve where there's the temperature, the weather, and then how much liters of ice cream you expect to sell. Right? And so if it's like 15 degrees, you have 3 data points here. If it's 15 degrees, you expect to sell 5 liters of ice cream, which is really not enough for sustainable. So at that point, you really want to stay home. But if it is 20 degrees, actually that gets interesting, 20 liters. And then if it's like 40 degrees, which fortunately we don't have today, you'll sell 25. And with that, you can kind of interpolate and extrapolate every day how much ice cream you sell. So if you want to write this and you want to automate this, you would write this kind of program, which I will call the software 1.0 program. You would say, well, if it's less than 15 degrees, I will just stay home, because then I expect it's not worth the business. If it's larger than 15 degrees, I have these data points. If it's bigger than 30 degrees, I'll order 25 liters, and otherwise I'll do 10 liters, and then I'll just sell the ice cream. Make sense, this program? Everybody understands this kind of, it should be simple enough, and you're all hackers, right? So that should be okay. So what is the software 2 variant of that? And I will briefly discuss why this is so good, that variant. It looks like that. Instead of kind of saying, well, we're going to program this data and we're going to hard code it into the program, what we'll do is we will apply machine learning, we'll create a model, and we will learn this graph. Essentially, we will learn this function. That's what machine learning does. It learns a function. So let it do its job, and then let's do the inference, and that's the first line. Let's just predict. Let's tell a function, please tell us how much consumption will there be today. And then I'll say, well, if the consumption is less than 5 liters, I'll stay home, because that's my business decision. It's not worth it for me. I'll rather stay home. And otherwise, I'll just order the predicted consumption, and I'll sell the ice cream. And then what I will do is I will retrain my model. I will learn from the experience that I had today, and that experience I will feed into the model to make a better model, and so that my business gets better and better. So comparing these two programs, which one do you think is the better program? Well, obviously it's the software 2.0, but the question is, why is this better? Right? It doesn't look that much better because they're almost the same in complexity. They're equally long. And there's actually also an if-then-else statement there, so you will never get completely rid of it, but it is a much easier kind of if-then-else statement. So here's the first argument. The first argument is that the right program actually separates our data-driven, kind of our experience, much better from the business logic. Yeah? So essentially there are 3 statements, this prediction and the recording and retraining, which are pretty generic. They have nothing to do. They can be programmed by a monkey. Yeah? You don't need to make any kind of decisions on, well, what is a good consumption? How does the flow of ordering ice cream selling? You don't need to know anything about it. All you need to know is you need to have somebody who understands that consumption depends on temperature, and then you need to build the models, but pretty much these 3 statements are generic and are completely independent of the application logic. On the other hand, in the left-hand side, this is all woven in, and of course that is a problem, because if the consumption behavior changes, let's say I develop a completely new ice cream flavor, and suddenly people will buy ice cream even when it is 5 degrees Celsius, and they will buy that because it's such a big fashion to eat ice cream. We would have to really change the left-hand program, whereas on the right-hand side, the model would hopefully kind of learn that we have a new fashion and that we need to go for it, and we wouldn't have to change a single line of code. Which is good, which is exactly what the separation does. Okay, that's number 1. I hope everybody understands that advantage. And I want to come to a second thing. And if you look carefully, you see that the criterion for the staying home is different in the left and in the right program. And in the left program, because you kind of optimize, or in some sense, and I think as you're programmers, you know all about this, you took a corner. You said, well, really, I want to stay home if the consumption is low. But I know from the experience that the consumption is low if it's less than 15 degrees. But again, you will have this problem that if something becomes in fashion, you would have to reprogram that, and that's really hard to find, right? These kind of adaptions. Whereas on the right, you're really programming the business intent. The business intent is stay home if consumption is low. The business intent is not stay home if it's cold. If the business intent were stay home because it's cold, because otherwise I'm going to catch a cold or corona or things even worse, yes, then we can still program it, but we have the freedom to program it. Whereas in the left world, if you wanted to do that, you would get a very complicated, even more complicated and nested program. So this is a reason why I believe if then else is complicated because often, and in some sense, if you go back in the history of AI, historically, like in the 70s, people wanted to program AI with if-then-else statement. They had these rule engines, right, which were big switch statements, if you think about it. And what we've learned in the programming the impossible is that that is bad. At some point, there are just too many conditions, and it's just too complicated. And what I'm kind of saying is something really simple. What is bad in the programming the impossible when things get very complicated is also bad in the programming the mundane, where things might not be so complicated, but at some point, and you know that, every program gets complicated, so apply essentially the same idea and the same logic to that. So this is a little bit stepping back. If you compare the two, there are some very interesting kind of phenomena. So the complexity of software one grows over time because you find more, you refine your program the more you learn about your environment. And that's why these programs get bigger and bigger. In software 2.0, the programs actually don't get bigger. You just collect more and more data, and the program doesn't change. And it actually, all that happens, it gets better, right? Because with more data, your predictions get better. The adaptation in a software 1.0 program is explicit. You as a programmer need to change something. In the software 2.0 world, it is implicit, and that's what we want to have. We want to get better. We want to lie on the beach, drink our caipirinhas, and our world just gets automatically better. That's what we want. We don't want to work for making the world a better place. Software 1.0 is expert developers, experts in the business logic, but also in understanding these complex workflows. In the software 2.0 world, people hopefully at some point will just be able to focus on their business application. When do I want to stay home? How much extra ice cream do I want to buy to have some padding and security? And then I talked about the hardware aspect. I'm not going to go deeper into it. Of course, the software 1.0 was for an x86 processor. But really, the cheap processors today are where you get much more computation for your dollar, accelerators like GPUs or TPUs or whatever, ARMs and whatever else we will come up with. So with that, if you look at the history of programming, it is really, innovation has been to provide less features. And of course, the title of this talk was inspired by Dijkstra's famous go-to statements considered harmful. I think that was sometime in the 60s. So that was the first. Then we had object-oriented programming and information hiding, which again forbids something. There was no way to access a state variable, which is a class variable, which is information hiding. Rust, who is here a Rust programmer? Yeah. So what is the beauty of Rust? It forbids something that C++ allows, and that makes it much better to program. Yeah, and it forbids the modifying shared variables or shared objects. And now software 2.0, I think really, if you want to boil it down, it is about eliminating, to a large extent, and I'm not saying all at this point, and so drastic as it has done in the other approaches, but for first, we're still at the beginning, if-then-else statements. And why is this happening? There are a bunch of very powerful trends. So with that, thank you very much, and now I am actually happy to take questions if you care, right? Thank you very much. So are there any questions? Yeah?
So one question about the implicit adaptability. Are there any situations where you see that maybe the problem is because you train from the data that the adaptability may be too slow because you need to, you cannot explicitly modify the logic as soon as you know you want to change something, so it depends on the data and it could take longer.
Yeah.
And the second part of the question maybe it also opens up to a new class of, let's say, adversarial attacks, maybe for insecurity.
Yeah. So let me repeat the question. The question is, well, if this shape of this curve changes, right, it might be just like a small hype, yeah, like a new ice cream flavor or AI or blockchain might be a small hype. How do we make sure that we adapt quickly enough so that we take the hype, but also not too much to kind of unlearn everything that we've learned in history just to do, now everything is AI, right? If we would only do AI and blockchain, Microsoft would be bankrupt, right? Because we still make a lot of money on Word. Things haven't changed there. That's the first question. And I think the second question is related, is, well, people can game the system, right? And there are adversarial attacks on data, right? There's these famous things where you add a little bit of noise to an image, and once you do that, the classifier, you as humans don't see a difference in the image, but the classifier makes out of a monkey an elephant, right? And these are examples. And I think both of those are valid concerns, and they are both essentially the same question. And the answer to that question is yes, you have to work on that. We need to innovate in machine learning. We need to continue to do that. Yeah? And we need to do that at full force. Also application dependent, right? Because it's going to be different in applications. What does it mean, adversarial attacks? It might be politically really, really bad, or it might be business bad, and you will have different rules. What I'm saying here is maybe it's essentially this argument here. What you want is, you want to deal with these, you need mathematicians, you need statisticians, you need a little bit, they need to work with the domain experts, but you need a very special kind of talent that deals with that. And all I'm saying here is you want to separate that talent, you want people, super highly paid mathematicians, to work on that and to concentrate on that. And then once they've solved and they've made progress, you want this progress to be automatically, in the best way, to be kind of impact your software. And the others who are like me, not as smart, right, and cannot deal with all this, all these adversarial and so on, they should just focus on their part. So what I'm saying here, even I completely get it, but those are fundamental problems for any kind of software. Because also the software 1.0, I mean, solution not adapting at all or just making it human doesn't make it much better. These problems are very difficult problems, but let's organize the work in a way that we can solve them in the best possible way. And I think the software 2.0 world organizes the work in a much better way. Okay, great question. Yeah. No.
So it's kind of accepted that it's hard for humans to understand how some models get to the decision that they come to. So I'm wondering, how do you think debugging would look like? Because you cannot know if you get an unexpected result, if that's because of the model decides on something that you didn't expect or because your code is wrong.
Yeah. Super question. And there are, of course, several layers of answers here as well. So the first one is actually, we are working a lot on explainable AI. I mean, with these deep learning nets, that's all black box, but you can actually have variants that are almost as good or sometimes even better and that are explainable. Actually, regulatory compliance accepts that. If you kind of reject a credit application, you have to explain, oh, this person has a beard, I don't want to give a credit to that person. Yeah, something like that. You have to explain it, and then that might not be compliant, or it might be compliant. But the second, and those tools will help also debuggers. Of course, you will debug this in the same way as you would do the normal things. You will step through. And here's actually my bigger answer to that. And the bigger answer to that is, and that's also why I'm propagating that, is you will still need to do modularization, and you will still need to worry big time about your software architecture. And this is completely unchanged, right? If you, let's think of the old world of debugging. You have, let's say, a program, 100 million lines of code, one function. You're not going to be able to debug that. So what you do is you modularize it, and you have many classes, and you structure, you architect your program, and you do that completely independent of whether this is software 1.0 and software 2.0. And what I'm arguing, that's exactly what I'm arguing, that you will need to componentize also your models. And this is where I believe that public discussion is a little bit misguided at the moment. We want to build these super models, right? The GPT-3 and whatever OpenAI does that are as powerful as the brain, right? And we think of the brain as being one black box, and we want to create those models. And I think those you cannot debug. There's nothing you can do. We cannot debug our brain. I mean, I wish I would debug the brains of my children and understand what they have in mind, but I can't. But these kind of things you can debug, and it goes back to the question we had before. You can put data science on a predict consumption, ice cream consumption function. That is something concrete where you can work on. You can tune the rate of adaptation, but also you can debug the data because it's probably going to be much less data. And it's the task is much more specific. And so I think you have a chance there to debug it. Debugging the whole complex human AI or artificial general intelligence, I don't think is going to be, it's an important problem, but I think here a good software architecture will again help you to debug, but it will be slightly different debugging skills, right? It will be data science debugging skills versus the traditional logic stepping through looking at variable names. Okay, if we still have time for a question, I'm happy. Yeah.
Sorry, would you consider? I mean, something like that, Software 2.0, you can do today, right? With the programming languages today. Do you see in the future that this becomes more of a language features, like embedded into the programming language itself to support these models better, or will it be just, let's say, kind of a different approach, but basically using the same programming languages that we have today?
Yeah. So to a first approximation, I mean, I don't know. It's a great question, and I don't know the answer. But what I would do, and what we are doing in Microsoft Research, is really using the existing languages. I don't see that you need to reinvent. Although Rust taking that out is beautiful. You take the existing, but there is much more there's additional tooling, right? Like Visual Studio or Visual Studio Code, VS Code. They will have kind of templates that will allow you, or that will make it much easier to structure your code in that way. So at the moment, I see it more as a tooling. And in particular, if you look at this data science, I mean, there's a big pipeline, value chain of data science, collecting the data, managing the data, and doing all the things that you mentioned in your first question. That's a big tool chain that we need to create. So I, at the moment, don't see kind of a huge revolution in programming languages necessary, but you never know. I mean, who could predict that Python after 20 years suddenly becomes the AI language, right? So that's hard to predict. But that's how I would go about it first, to look at tooling rather than new programming languages. Okay, another question? Yeah, go ahead. I'm fine. Does anybody else have a question, or then we'll just take?
So the software that you present here works and can be written by an ice cream shop that has been established and that has been selling ice cream for a few weeks or months. But if you're just starting out selling ice cream, you can't write this software. You basically are forced to go with software 1.0 or buy data from somewhere else. How do you bootstrap this?
Yeah, but this is a little bit like the question before. I think if you're in the software 1.0, you also need experience to bootstrap. That's not a kind of software 1.0 doesn't solve that problem. Just because it asks you to hard code the experience, it's even more important that you have that and you need to bootstrap. Just to kind of go this misconception, you still need to know on the first day how much ice cream. So you're exactly right. You already gave the answer to your solution, to your question. Either you have to learn over time. That's why startups need venture capital, right? Because they don't know, and they need to experiment to find out what the market is like. And that's what venture capital does. It burns a whole bunch of, because you make mistakes in doing that. Or if you're kind of in an incumbent market that already exists, well, then you buy data or you hire people, which is kind of a form of buying data. Like what did Tesla do? They hired car designers from Daimler and from all the big manufacturers because it's hard to buy. You need experience to design a car, and so you buy, in some sense, the data that is needed to do that. But that's independent of software 1.0 and 2.0. You need to do that in any kind of world. You need to start somewhere, and there are different ways to start. You start random, or you start with something, and that's a business decision and depends on many other things. Okay, I think I don't see any other questions, so I hope that was kind of a small break. Continue and hack on whatever you're hacking on at the moment. Thank you very much.
Langsam, nur nicht hetzen, Leute. Das machen wir ganz mal obenrum, ist einfacher. Ja, das geht doch, so sieht's aus, korrekt. Want to test. Where's everybody leaving? No ice cream. No ice cream. Jesus. Guys, come back. I love you too. No? Okay, should I start actually? Or do we give people time to pee and get a coffee and all these things between sessions? No? What do you mean you don't want to let the people go for potty? Seriously? Did you have an AI prediction model for that? No, okay. That was too much. Good morning, everybody. That sounds good. So it's really, really happy to be here today. My name is Boris Bielik. I'm head of innovation for MongoDB. I did a very, very long trip from Riffersville over the Uetliberg to Zurich. So I'm actually local here, and that's one of the standard questions we get actually regularly. There is actually a MongoDB in Switzerland, there is. And today I'm talking about data is eating the world. So I will not talk about software 1.0. When you see no hair left, it's more like software version 27.0. So obviously you have to start a presentation on a Saturday with some intellectual statements, which I will try to do. Not as intellectual as my pre-speaker. Mark Andreessen, it's always good to quote somebody important, made an interesting statement. Software is eating the world. That was 2011. That was a last century in software speak. And at that point he said basically that companies becoming software companies, software becomes more important, it doesn't matter which industry you're in. And you learned just before from the previous speaker, ice cream is by now a software product. That was a joke, you're allowed to laugh, thank you. And I bring up now a little bit a word which came out from Elliot last year. He said, well, data is eating the world. Because when you take a look, in the 2010s, people became software companies. And by now, when you look at what happens with data, software companies become data companies, data-centric work. And that's honestly the part which is, for me personally, after doing 30 years relational databases, yes, I'm old, doing things like MongoDB, which I'm doing very happily. And when you take a look, several years ago when I was at IBM, I talked about people, well, in 36 months, data will be doubling. By now, we're doubling every 12 months. And if you ask me going forward, I tell you in the next 5 years, we will start doubling every 6 months or every 3 months our amount of data. And that is actually a wrong statement. We're not only doubling the amount of data, we are starting still to duplicate data all the time. And when I talk about data duplication, this is for somebody in databases the same thing like peeing on the stage. You don't do it. Data duplication means you copy data around, you have redundancies. What do you have immediately? Data out of sync. The second you copy data, you are out of sync with something. So in that regards, we have to see what's happening. And when I tell people, oh yeah, we're moving to the cloud, my joke is normally shift and lift, a lot of pain and no gain. Yeah, it's a really kind of cool thing, right? But the key thing is, it doesn't help you to move to the cloud. We are now digital. Oh, what do you do? Yeah, we sold our data center to a different provider. So when you see stupid statements like that, it's not helpful, because slow data, rigid data, stays slow and rigid data. Siloed data stays siloed. And yeah, vendor login, blah, blah, that's marketing. But when we take a look what us really hits as developers, it's really the point that data itself become a problem. The speed which data are moving. When I started with banks, mainframe. Somebody remembers the mainframe here? You know, these big black boxes? Oh yeah, bro. Yeah, we're in. So when you see those systems, they were end of week processing, then came the end of day processing. By now, we're talking velocity. I need 50 milliseconds delay. Otherwise, my counterparty credit risk is called Lehman Brothers. So when you see these things changing, the scalability, what we talk about, there's so much things happening that I came up with this slide. Yes, actually, I came up with this myself, not the marketing department. You see it? It's not beautiful, but it's useful. When we take a look where data came from originally, databases, it was all about high-density space. How do we get data compressed? How can we get data stored highly efficient? When people right now invoke the infamous COP article from 1970, this was probably before 2/3 of the room was born. I was already born, shame on me. So when we take a look back to these articles, they were all about optimized saving in tables to not duplicate data. Good approach. Then came a long development of relational database and came Oracle 6. Yes, it existed. And Oracle 6 was the last database in the relational space where actually there was progress. Now, people will say, Boris, you cannot tell me that for the last 35 years there was no progress in relational databases. There was not when you look in the fundamentals, tables, views, materialized views, statistics, hints, buffer pools, prediction, pre-selected calls, pre-buffering, all the funky stuff's what's happening there. Nothing happened since then. And when you look afterwards, people try to get funky. Yeah, we have object models, and there were these rogue databases called OODBMS, which sounds totally cool. They came and they left. There are some niche deployments still today, poor guys. And then somebody came up with a brilliant idea called XQuery and XPath. XQuery and XPath was the perfect way how you don't want to deal with your data. In a notation, which you need a scientist for, you need about an hour to get a query written, and after you really feel really bad, somebody tells you that's not working. So that was the time of the XML. After that one came a revolution. People realized we cannot continue on this path of strict structures, and people came up and says, we do Hadoop. Everything is flexible, everything goes. Problem was, it wasn't all bad. People then backfired. And this backfired is a little bit like Robespierre, right? That was his dude who put Marie Antoinette on the chop, and then afterwards got chop himself. So the same thing happened to the big data dudes. Big data came and got chopped because it was too unstructured and didn't have enough infrastructure. So when we take a look what we're doing with MongoDB and what our philosophy is, we're trying to bring in the good stuff which helps in a database world, in a data platform world, in a data structure world, where we structure queries smart, have asset compliance, have security. These are all the table stakes. And this was where relational database were really awesome. We all agree to this one. But then bring in the dynamic, the flexibility of data types, of GPS data, of all the various things I have, movies in documents, PDF embed, whatever. And the scalability and the performance from the big data systems. The largest systems we run today are going up to 10 petabyte. I have a client asked me already about exabyte. I think the guy smoked too much, but yeah, they will come out eventually. But right now, most systems we see are still below the 150, 200 terabytes. That's still the sweet spot, I think. That's still a lot of data. And then always on, global distributed. So this is what we're doing. And what we try to give you here today, and This is now not marketing. You guys know we are out there, and you can get actually pretty cool swag back, small advertising. Just get the little sticker and get your swag back. But the core of it is a database, and most people know that. MongoDB, yeah, I know, database, transactions, great. The other side is integration with search, data retention. I always challenge people to look into a bigger picture, to look into, yeah, okay, I have a database. What are you doing with your data? What do you need for mobile? Oh, yeah, right, mobile. Yeah, we're building our own synchronization right now. Question number one, why? Why do you build your own synchronization? Take it off the shelf. MongoDB Realm, totally cool, totally woke, developed in Copenhagen, European product, can only suggest, and use that one. Direct integrated, save yourself the work. Oh yeah, I need to build the data analytics. Why? Why do you copy data? Yeah, well, I wasn't sure how to integrate. I need to keep my data for 7 years data retention. Some countries in Europe, 13 years. In Australia, in some provinces, 99 years. We're getting into a complete different problem zone. But when you say, look, I need to keep 7 years my ice cream purchase from the gentleman before me, then you need to think about retention. So data lake comes really into play. Everything what we talk about here embedded into a development structure and into tools for AI and such. One comment about transaction. I hate that. People ask me, oh yeah, MongoDB, can you guys really do transactions? First thing is, MongoDB since 2015 transaction safe. That's actually MongoDB 3.0. I always say 3.2 because I believe there were some changes which are very critical. That's esoteric. But the key thing is, we are running by now as the only database globally distributed transactions. Think about you want to do a currency exchange between Australia and Zurich. They still have Australian dollars. Soon they will move to Swiss franc, I'm sure. But assuming so far we have to do something, you have a bank account in Australia, a bank account in Zurich. We can use this in one account, in one structure, in one transaction, and bracket it with a nice commit. This is something what nobody else can do. A lot of databases, pretty much everybody can do a two-phase commit. The interesting part is, can they do it globally distributed in one database? And that's where it's becoming exciting. So yeah, we're moving trillions of dollars. A lot of payment systems in the world run by now on MongoDB. That's not that somebody has a picture server on a website, but really run transactions. Money is moving over that. And yes, government services using us as well. But so if you ask, can I do transactions? Can I do reliable infrastructure with something as MongoDB? The answer is 100% yes. And I'm more than happy to have afterwards some religious discussions about it. Document data model. Do I have to go into this one? Say no. Say no? Oh, that was a little bit low. Okay, so now you have to listen to it. So everybody knows JSON, everybody knows document models. What people don't realize is MongoDB has data typing. And this is important when you look into applications, healthcare. Think about railroads. You don't want to have accidentally some misalignments on some timings. So we have data types for time, for decimals, for real, for position, all this stuff. We are not transforming things into strings. That's the most important thing you need to know. Because if you pull a document out of the database server, you use it in your application, you get them in exactly the type in real time as you used them before. You don't want to have, because there is a real adjustment between platform A, platform B, and whatever, suddenly get a different value. If you have 4 digits behind the point, you want to get 4 digits and exactly the same 4 digits out that you had before. This is a part of the heritage of the relational world where we are very proud of and which is absolutely critical when you work with data. Think about healthcare data. You don't want to have suddenly, well, yeah, we adjusted a little bit the color coding and some of the shades on this noise X-ray are gone. Really bad choice. So these are the things where the document data model is important. On the other side, it's very intuitive. I had a discussion yesterday with an interesting large banking organization, and the dude asked me, so how do I really do this migration? He says, well, persist the object. He says, no, I get that. I understand the persistence problem, so what do I do? I said, okay, step 1, open database connection. FOI, you don't even need to create the database. Just open the connection to server database collection created. Step 2, persist the object. Line 2, The end. That was when it came in that all this thinking they did before about models, they have done the models already. It's intuitive. It's inside their operational business logic. So they don't need to do something. And it's universal. We can do anything, and it's very robust. So again, what are we doing? Flexible data model, rich querying, indexing, everything what you need around that one. So we have a lot of capabilities. The fun part is when I'm dealing with startups or small projects or hacks like here this weekend, is when you bring different things together. When you have data coming in out of some IoT devices, meshing up with geo information, meshing up with human information. That is when data become the core, when data is the new oil, and when data is eating the world in the most positive sense. And this is what we're delivering with all the capabilities on indexing, views, and all the things around. I would like to bring up one thing here, aggregations. This is my personal peeve, I admit it. Whenever you have data in a database, you need access to the data. One of the biggest things where people stumble upon is yeah, but I want to use my select star from table where, and yeah, then I need to group by and assort ascending. It says, dude, you realize this is a really bad thing. Yeah, I need to do a sum distinct, which is a full table scan, and then I need a count distinct, and I have a Cartesian product. And then I tell people, you don't need to do that. You just use aggregation framework, which is very simple. You have a database, you have some data. In this case, you have some things with status A and D, maybe arrived or deleted. And then it tell me just reduce down to everything which is arrived. So I'm getting 3, and now I'm doing a count distinct over the whatever units were shipped, the sum of a total, and I'm done. That execution is index-driven and is not leading to a Cartesian product. These things are bloody fast. And then I can substantiate the stuff into a nice materialized view and work onward. And I can keep these updated, quick, fast, in nearly real time. The other thing what we have is JavaScript functions, user-defined, much, much easier to read than relational, PL/SQL for Oracle or whatever else people suggest. So I can only suggest this. Now the result, what I talk about is data deduplication as a platform, and I call this a microservice data platform. In this case, you have some data domains where data floating high speed or slow speed into a relational data store. The relational data store has additional nodes attached for analytics. No copy, real time. To give you an idea, a fraud detection system we are working with for a very, very large organization, we have a 50 milliseconds delay between the inbound transaction bracket closed, copying into the analytics nodes, checking data science system, scoring the data back, re-enriching the data, going onward processing over change string capture to the right side. 50 milliseconds. That's good enough to be even incorporated into personalization when you think about mobile applications. 50 milliseconds is kind of free. And then we can go further and saying, look, we have these data, but now we have our 6-month-old data. And yeah, we are really not that hot on those, but we need them. We need them for back testing with our work, what we're doing around data science and machine learning. We need those data for regulatory reason maybe. So we slowly push them down into an online archive, and after 6 months, we move them down into the data lake. In parallel, I have the integrated Lucene engine. I can do full tick search on all the data fields in real time. That means that if you get data added, think about a sales receipt, think about a healthcare data set, whatever you're dealing with, you have this data completely searchable immediately on the system. And then on the outbound side, you have all the different mechanisms for using microservices directly attached to the data structures. The difference is you don't need translation, you don't need interpretation. You win normally about 100 to 120 milliseconds on that side for your communication. And then you can make these services available flexible to everybody. You become a microservice data platform versus a monolithic data platform trying to serve to different APIs and have discussion on data formats. As you can realize, because of the JSON format and the concept of enrichment, the data becoming very flexible in that infrastructure. We don't have delays. You can be everything for everybody. You have a Rust application, a Go application, a .NET application. Yeah, they still exist, sadly. And you have a Java application, you have whatever, Swift. And so did I mention enough buzzwords to make it? Yeah, okay, good. So at that point, we have all these languages, but we have no need to build additional intermediate layers to access this data. We can go native onto the store. There's not a Microsoft Entity Framework. Anybody ever used that stuff? Yeah, no, nobody says something, nobody dares to. Yeah, I'm honest, I did. I recovered, took me a while. So you don't need anything like that. No Hibernate, no JOQ. All that stuff is gone. And the second part is obviously what's very important for myself is data science AI. MongoDB has cool integration for Python, R, and all the other tools what you need in that space. Nice logos in the corners, always good on a slide. And the key thing is we can integrate real-time behavior out of the transaction over the analytics nodes, what you saw before, connecting into a data science platform, do work there, get the results back, and continue to react to the change, whatever comes in. And this is something which, in my opinion, was impossible before with other platforms. It's all about the real-time capabilities, cloud capabilities on that space. So I have to advertise now. We have MongoDB University. I can actually suggest it. When I started MongoDB 2015, I was stuck with SQL Server, Oracle, Java, .NET, and tried to make sense out of it for my employer who pays me money at that time, very nicely, I admit, and brought the things together. And then I came and says, screw it, SQL out, Oracle out, bring MongoDB in, and we had no skills. So we used MongoDB University and just to get up started. Today we have a special course called M100. I call this the about 2 to 3 beers and you're done course because it takes normally about an hour. Nobody's laughing, okay, I tried. And then at that point, we have, after an hour already, enough know-how to be dangerous enough to not get stuck anymore in the relational model, which is still taught in school, sadly. And how do we onboard you guys? You heard about the M100 course. It's 1 hour. I was too fast. Red wine is 8 hours. We have these swag bags in front of the door. So somewhere you have to get these cards and you can register for your swag bags. And there's a link as well. You can go as well to my colleague Gustavo, who's somewhere around here as well. And you have free access to cloudmongodb.com. If you need help, go to the Slack channel. There's a MongoDB Slack channel where colleagues of mine sitting online and waiting for your needs and feeds, as well as discussion. If you have questions, there's some awesome people, Felix, Benjamin, lots of others. There is actually lots of know-how in Switzerland. You will be surprised. And at that point, enough marketing. Thanks, guys. Open for questions. Thank you. Anybody? No? Nobody? Not one? No pro forma questions? No? Who is using MongoDB here from all these thousands of people in the room? Oh my God, everybody. Yes, awesome. Yeah, remember guys, this gets streamed. It's very important to give some noise. Good. Thank you, guys. Bye-bye. Front of the screen, I'm on the side with a coffee.
Okay. Ready? Okay, so then, all right. Thanks everybody for staying here for the next tech talk from Microsoft once again. And hello to everybody on the live stream here. The next, I think, 30 minutes or so, we will talk about something that is really cool, and I'm really happy to present it to you. Just a few words before we start. My name is Florian. I'm Developer Audience Lead here in Switzerland for Microsoft, which means I care about our technical communities, make sure that everybody has connection to communities, and there's a safe and inclusive space for exchanging ideas, from learning from each other through meetups, conferences, hackathons, things like that. Just wanted to point out a little bit, we have lots of learning materials if you want to learn about Microsoft technologies like Azure and all the services we have there. And want to remind you that we love open source these days. So if you are, whether you want to use Microsoft technology or open source technology, we have great services. And today's talk about Azure Static Web Apps will also be mostly or almost exclusively about open source technologies, as you will see. If you build something on this hackathon using Azure or did some tutorials and learn, feel free to ping us, and we can give you some super cute little Azure Heroes badges, which are digital collectibles that we give out to people building and learning about our technology. All right, so what I'm going to talk about in the next minutes is probably the framework with the most underwhelming name. So when I first read about a new service on Azure Cloud, it was called Azure Static Web Apps. I was thinking about like, well, static, that sounds kind of, back into the 90s. So before PHP was invented, we had kind of static web pages, right? But that's not the truth. So this is probably the most underwhelmingly named service on Azure, and I will try my best to get you excited about it. All right, so now exit presentation mode and open something like this. Now let's start with a blank page. So the story goes a little bit like that. You're a developer within some kind of financial institution in Switzerland, and you're waiting all week long, sitting in your office, poking your nose and trying to figure out how long it takes to really redeploy that monolithic application you have there. And on Friday, it's still somewhere stuck in the process, and you decide, oh, I don't like that. I want to do something fast. I want to build some cool idea, and I don't want to wait a week with slow processes and old tools and outdated platforms. So you decide in a coffee break, you meet your CTO and tell her, well, I'm going to do a hackathon on the weekend. I want to do something cool. I want to do something fun. And she challenges you and says, well, cool stuff, but let me ask you, show me how fast you can go from zero to a productive web application or to a productive application that is not just a prototype, but you could actually put it into production, and you could actually use it to build and scale the idea you have in case it's successful. But keep in mind, it's not just about hacking things together. You need to take care of a few things. I want you to make sure it's like your files are globally distributed in a CDN. You need to have a CI/CD pipeline set up. You need to make sure that there's authorization mechanisms for your APIs in place. And all this kind of stuff that you would have to build for a real application. Good luck with that. I'm pretty sure maybe on Sunday afternoon you will have your environment set up and everything is running so that you can finally start doing your, implementing your application. And you think, well, no, I have an answer for that. And you have the greatest idea ever, and nobody has heard of. It's like the solution to everything, it is containers. Great, right? So, no. Okay, actually, that was my attempt of a joke. In fact, this is the last time I will talk about containers in this talk. So no containers, no Kubernetes. We talk about static web apps. And Azure Static Web Apps is a framework, and it basically gives you everything that just talked about. The idea here is it combines a few of the platforms and the tools from Microsoft, Azure, together with GitHub. And on a very high-level scenario, it works a little bit like this. You use GitHub obviously for source control and versioning, and branches using feature branches and pull requests and all the things that you may know from GitHub. You have GitHub Actions, which is your CI/CD pipeline that as soon as you push or merge a pull request into your master branch, it starts building and pushing out your application to Azure. And on Azure, you have basically two components. One is the static component for your web application, which is all the HTML, JavaScript, CSS files that you want to, have distributed and globally and being fast to load for your end users. And you also need to have a backend API. Where your front-end calls the back-end, where you implement some business logic, or where you make some call-outs to databases or cognitive services or whatever you want to do. And this is actually implemented with Azure Functions, which is serverless technology. So there are a few out there, but we have Azure Functions, which is pretty cool because it frees you from the responsibility of managing containers or servers or anything like that. You just write your function. It gets triggered by HTTP requests in that case, and you're good to go. So this is on a high level what Azure Static Web Apps is about. And the best thing about it is, if you really think about it, about those two components, static content and the Azure Functions API, if you use it for a hackathon or for a prototype or a hobby project, it is basically for free, because hosting static content, it's super cheap. Like whatever files you have, usually for a normal web application, it's well below the free tier limits of Azure. Same goes with Azure Functions. It has a high free tier, which means unless you have let's say 1,000 users or say kind of load tests hitting your application, it will be still within the free tier and not generate any cost basically at all. So it's also very cost efficient to start with that kind of approach here. All right, so this is what I talked about. There's a website about static web apps. It's currently in preview, which means there may be some features being added, but it's pretty stable. We use it already for a lot of prototyping and a lot of applications. And it says it's a modern web app service for streamlined full-stack development from source code to global high availability. And all the heavy lifting, it basically does for you. It scales dynamically with the serverless APIs. It manages global availability of your static content. It integrates seamlessly, as I said, with GitHub, with CI/CD. And it has some kind of nice goodies that you usually start implementing as a first step if you really build an application, like custom domain and TLS certificates, authentication and authorization, a little bit basic, so you want to have some pages that are only for logged in users, and you may want to use social logins for that. And we all know how to do that. The point is, I will show you how to get from zero to that in like 5 minutes flat. And for that, we start with a demo application. And this is actually the Micro Hackathon Starter. This is a starter template or starter application we built for the challenge that Micro has on this hackathon. It is basically, the app itself is basically just a collection of links, how to access the data, and some kind of links to documentation to some interesting services. So this is not particularly interesting. Could be anything. It's just a simple web application. But here's the instructions how to clone it and how to get your own instance of this running. So you head over to the repository. And the repository here is a normal GitHub repository. I will go into detail what is in here in a second. But you can just use this, say, HackZurich demo 1. Let's see, that's available. So clone this template repository into a new one. and then deploy it to Azure. So there's our new repository, and we deploy it to Azure. Yes, that's me. All right, and if you have used Azure anytime before, you probably know some concepts here. So you need to have a resource group where everything is kind of put into. We give it a name, HackZurich Demo 1. We give it a region, West Europe. And then we have to sign in with GitHub. And this is because actually what GitHub, it's connected to your GitHub repository, and it actually writes the configuration for your CI/CD pipeline into your repository. I will show you in a second how that looks. HackZurich Demo 1, exactly, that was it. And we take it from the master branch. And here, this is an interesting part. You remember there are basically two parts. One is the front end, and one like the static content, and one is the serverless backend. For the front end, on the static content, you can basically use whatever JavaScript or web framework you want to use. You could use Angular or React or Svelte or Vue or Blazor, or you can actually use it without the serverless backend API and just use a static site generator for really static sites, like you just want to use a generator here. The point here is that in the end, the only thing that is required is that your application can be built using NPM, Node Package Manager, and that you kind of configure where is the output folder and where are the artifacts located. So the build step from your front end will generate some static files, and we need to tell the static web apps where it will find these static files. That's it. So now we say create. I hope this looks good. Yes. And in like 2 minutes or so, we should be having up and running new static web app with a CI/CD pipeline, with your serverless backend, and some demo application, front-end application. Go to resource. All right. So this looks like it worked. So this is the web portal of Azure. You see the overview of everything you can configure with the HackZurich demo static web app. And I will go into detail about some of the things that you can do later on. But you can, for example, you have configuration variables. You can configure custom domains. You see your functions, your Azure functions. You can actually have multiple environments, and this is pretty cool. So, for example, when you open a pull request, your branch gets staged into a staging environment, and as soon as you merge the pull request into the master branch, this gets pushed into production. Nothing to configure, all taken care of you out of the box. So this is the application. You see the URL here. Let me see if that works. Yeah. So it's still building, so it's not ready yet, but the URL is ready. And now we can look at the workflow file. And this is generated by the creating of the application. And you see this file here in your repository is actually GitHub Actions. It uses GitHub Actions to build and deploy. Uses some tokens and secrets. It's configured for you, and it has your application settings configured here. You can modify this file to have a more sophisticated CI/CD pipeline, of course. This is just a start, and it works pretty well for the basic use case. All right, so let's see, actually we can have a look. The actions should be running already. So this is my pipeline here, and if I look at my pipeline, this is actually what happened, and it looks good. So it builds the static web app, it checks it out, and it deploys it to Azure. That's basically it. Sorry, I lied to you. So there's Docker and containers involved under the hoods, but yeah, you get the idea. You don't have to care about it. All right. So just imagine, now you could go on and check out this repository from GitHub into your local development environment. And I already did that for the application starter from Micro that you just saw a few minutes ago. And I will walk you a little bit through what's in the code and what's happening here. So as I said, we have basically, well, there are 3 things to talk about. The first one is .github/workflows, where this is where there's this, as I said, this GitHub Actions pipeline. When you create it the first time, this will get created for you. And from that point on, you own it and you can just modify it and work with it like with any other source code artifact. Then you have API and app, which is how I structured my application here. The app is actually the front end. Let me close that. And you see there's a package JSON. So I don't know, for people using Node.js and JavaScript on the back end and also on the front end, it should look familiar. So the front end is written with uses npm to actually build the static files that will then be served. So the resulting files of the build step will somewhere landing in the public folder. Here, public, and in the public folder, this will get generated. And some of the files here, you also can modify by hand. So for example, there's a routes JSON, which you can use to configure some backend routing, the routing rules of your application. And I will come to that a little bit later. It gets interesting if you, for example, want to have a login route for authentication using GitHub. And this is all of the box. You don't need to configure anything for that. So routes.json is important. The next thing is here under source. I mean, I use Svelte. I don't know, anybody heard of Svelte, web application framework front-end? I cannot see here. Yeah, it's the latest and greatest stuff. I mean, I could have used Angular or Vue or React. It's probably more popular these days. But I wanted to try something new. And it's kind of cool to check it out if you want. But basically, in the end, this is just one option to building like a templating language where you have something like this in your components, and then you build your front end. If you're a front end developer, you know exactly what I mean. And I'm not going into more details here. Of course, you can also test it locally. So I could, for example, let me see, npm run dev. Oh, maybe it's already running. Oh yeah, probably it's already running. Yeah, bad idea. All right. So this is, I can do npm run dev, and then it will run here on my local machine, and it will serve under, come on, before I look too far, just show it again. So this is my build step here, and this is basically what will also happen on Azure. Those output here is just warnings about me writing bad HTML code. All right, so this is localhost, and you see now this is my local instance of that application. And this is just the front end, so there's no back end. If I do something that would call the back end, it's not working, because locally, and that's the other thing to test, I have the Azure Functions local tools, which is in the API folder, as you see, and npm run start should run my API. And I come in a second what this is about. I don't know, did anybody use Azure Functions already from the audience? Azure Functions, anybody? Who knows what serverless is, like just in theory? Maybe from some other cloud platforms. That totally suck, of course. No, just kidding. So okay, so this is basically serverless, our serverless product, and you can test it locally with the local tools. So I can go to this address and test, for example, the backend API. So I search for Stocky. because I like the word, and here. So this is calling my local Azure function, and the Azure function in turn calls the REST API, just simply calls the REST API of the Migros data set. So that's how you get to the data. So you can test that locally, debug it, look through it, and just do basically whatever you want. Looking at this API, there are two things that are important. First is you need to create a file that is local and not checked into source control, which is called local.settings.json. This is where you put the credentials. And these are the credentials. Just don't worry, they're only valid for this weekend for accessing the Migros data set, but you get the idea. Those values here, they get injected at runtime as environment variables, and you can parse them. Let me show you a little bit like that. So you get these things like that. And this works, of course, locally as well as it works in the cloud afterwards. All right, so local.settings.json. You need to create it, and the first step that you need to do when you want to upload this now to the cloud and deploy it to the cloud, there are actually two steps. First of all, maybe let me switch back to the portal. Is you need to have the configuration, for example, for accessing the database or accessing the services, just as you saw in my local.settings.json. So here in the cloud configuration, it's not there. So you could manually just add those variables and those values here using the portal or the CLI tooling, but there's an even more elegant way if you use Visual Studio Code. Because Visual Studio Code has an Azure extension supporting Azure Web Apps, and you can just upload your local settings to the cloud. So this is what it will just push all the values here and merge it with the ones that are configured in your cloud instance. All right. So this is everything you actually need to do or you need to know about. Now you can start modifying the backend, like adding new API functions. So, for example, let me see. No. Function, create function, HTTP trigger, test, get, authorization at function level, and we have a new function actually. And it does nothing. You see here the binding. This is the metadata where you say this is triggered by an HTTP request. It's, by the way, the only type that is, or trigger that is supported for static web apps at this point. And your code gets called like this. It's a JavaScript function, and you can do whatever you want with the request and then send back the response. So nothing too fancy here. So I hope you get the idea. And once you have changed everything like that, there's basically two things you can do. For my demo here, let me think quickly what I will do. I will modify the front end very quickly so that you see the change. Let me see. It is getting confused a little bit. It is here under source. Home.svelte. I will do welcome HackZurich. I think that should work, right? All right. So you see outgoing change. Outgoing change is here. I commit and I push. So you can do it with Git command line, of course. And this is now, just to make it a little bit simpler, this is pushing directly to the master branch. What you could also do is work with GitHub pull requests, which would require you to make a feature branch first, start working on that, and then submitting a pull request on GitHub. And the nice thing about the way this is implemented right out of the box is the moment you commit the feature branch and the pull request, it will actually deploy a second instance of your application in a staging environment. So you have still the production environment, which is on the master branch, and you will have the, your pull request in a staging environment. And as soon as somebody approves and merges the pull request into the master branch, that will get, of course, deployed into production. So it's pretty cool. It's a basic workflow, but it works quite well out of the box. Now, that's what I did. Now let me head over to GitHub again. Wait, it's probably easier to go here. All right, so this is my template that is, my repository that's deployed currently, and you see it, added some fluff, that was my commit, it's already running, and it hopefully will succeed in a few seconds. So yeah, so it's building and deploying and making sure everything is right, and also reminding me that I should close my HTML tags and stuff. And but yeah, should be fine if the demo gods are with me today. Oh yeah, finished upload, polling on deployment, wonderful. Okay, and then a few minutes later, I hope. Yeah. Well, it still takes a few seconds. I'm talking too fast. Yeah, but you get the idea. So in a few minutes, hopefully, the new version will get deployed, and you will have welcome HackZurich here. It should be the right one, actually, because I cheated a bit. I'm not showing I'm showing this an update to the existing application. Yeah, here you go. Welcome HackZurich. Seamless, right? Okay, but that's awesome. But wait, there's more. What is actually integrated, and what I personally like, because when you start writing a new web application and you prototype for a hackathon, of course you don't polish it like totally, but you at least want to have some basic things like authentication, like users being able to log in and stuff. So let me open a private window and go here. And you see, this is the website, and I can log in with GitHub. And I have not implemented anything about that. I click here. It asks me about my credentials. I hope I remember them correctly. All right. And here I'm back. You see, logged in, and you even get an endpoint which is predefined. When I go here to .auth.me, this is basically the information I get. So I use the identity provider GitHub. I could use Facebook or Twitter, or I could also integrate it with Active Directory or some other identity provider I want to use, which is pretty cool, because we all know how to do it, but usually it takes a little bit of time to implement it. So it's easy to get started. And as you see, as I'm logged in now, there's a new menu entry here, micro product search, and this is just an example to actually call the backend API and get some information back. And this is so it has authorization for your Azure functions for your API built in. So I do it once again. I do log out and I say API/products search. It says 401 unauthorized, right? Now, if I log in and do the same again, API/product search text me. And I hope magic is going to happen. Hello. Try again. API product search. Okay, something is slow here with the web. Oh yeah, here you go. Okay, so this is what you get, and because I'm logged in, authenticated using GitHub now, and this is pretty cool. And let's go back to the portal. Let's go to the real one. Go to the hackathons, to the starter. So here you can see, for example, the configuration. These are what I said before. We uploaded those environment variables from our local settings JSON, the credentials. It also supports custom domains, by the way. I didn't show that. So you can, it renews automatically the SSL certificate, and you can connect it with your custom domain. It's really easy. And what you can also do is the role management, which means that you can say per authentication provider, I want to invite, for example, some GitHub user handle to this domain, and give them roles. And the roles are kind of free. There are two predefined roles, anonymous and authenticated, which just means if a user is logged in or not. But I can come up with mine as well. And then users get invitation links, and you can give them different permissions on your web app just right out of the box. And the way you would control that is with this file I showed you earlier, in the routes.json, it is here. So for example, I say the API routes, you need to be authenticated. Otherwise, you're not allowed to call them. And some other things you can do here with the routing. And you see here, this is a predefined route from Azure Static Web Apps. You don't need to do anything in the case of GitHub, for example. In the case of Facebook and Google, we also support that, but because you need to implement a little bit more, for now we have just disabled it. All right, so this is it. So everything I wanted to show you today about Azure Static Web Apps, I hope you liked it. I think it's pretty cool, especially if you want to hit the ground running with a new idea of writing a web application, hobby project, hackathon starter, that don't cost you much, because this is basically running for free. It's just a few static files and Azure functions, and as long as, let's say, less than 1,000 people call your Azure functions, it is well beyond the free tier. So it's a pretty cool and neat solution. And yeah, we will be here until end of tomorrow. And if you have any questions about that or any other technology on Azure, feel free to come to the booth or contact us in Slack, and we will be happy to help you. Thanks very much. Well, maybe we have time for questions, if there are questions. Sorry. Any questions? Do you have any more templates for Static Web Apps on Azure?
The question was if you have templates. Yeah, so basically there are a few of example repositories. I mean, in the end, you can, of course, I didn't start totally from scratch with my demo here. I had my application actually written, but let me show you quickly. For example, this one, there are lots of those example static web apps. There's tutorials how to do it, how to use it with Angular, React, or other front end. For example, this example here is a so-called monorepo. So you have actually the same front end implemented in 3 different or 4 different front end technologies. You have Angular app, React app, Svelte, and Vue. And you have the backend API, which is always the same. So obviously, for me, for the starter for Migros, I just choose one. But it's basically, you can do it with any of those front-end technologies that you like. So for example, if you're Angular, this is your Angular front-end app. As I said, it only needs to be built by NPM, and you need to configure where the output of the static files will be, and then it should work with Azure Static Web Apps. And you can also choose not to use any front-end framework and just publish static content as well, if you like that. So there are lots of tutorials, like for example here on MS Learn, and some sample repositories and templates to start with if you're interested. Any more questions? No?
All right, then thanks very much for your attention. I really like the technology. If you have, as I said, if you have any more questions, feel free to contact us. If you build something on Azure or with static web apps or with something else, just let us know. We are always keen to hear what you guys and what you folks are doing. And if you need support, yeah, contact us. We are trying our best to support you. And yeah, happy hacking and looking forward to talk to you. Thanks.
So. Also kann das PowerPoint sein.
also on Zoom. I sure had some trouble getting up after last night's session, so appreciated that you did and that you're here. I'm Michael from Valora, and I'm going to tell you a little bit about how you could potentially build your own autonomous store. Now, Valora Digital is the innovation unit of Valora. We're a European retailer, more on that in the next slide, but we are really young and we have a lot of tech competency for a retailer. We're quite hands-on, so we are, like, as we like to say, builders and doers. So we don't do a lot of management type stuff. We go really deep into the tech and we try to get things done. I myself come from a startup background. I've been at every HackZurich so far and always having a blast, and also have a tech background. Topics we're working on are autonomous stores. That's the one we're talking about today. Then we have loyalty as a really important topic for us, e-commerce, and also process improvement. That's things like automated replenishment, where we do sales forecasts and similar data science type stuff. Valora has 2,700 stores across Europe. For those of you from Switzerland, you might know a couple of those brands like K-Kiosk or Brezelkönig, and those of you from Germany or maybe the Netherlands, you might know Backwerk or Ditch. And we're actually quite old. We're over 100 years old, and we're coming out of this kiosk group that started really early and has a lot of stores. Today, I want to talk about autonomous stores. Maybe quick show of hands, who of you knows about Amazon Go? Awesome, that's most of you, so I guess that's why you're here. The goals of these types of stores is getting a better experience for the customer on one side, so you never need to queue because there's not even a place where you could queue. You can have longer opening hours because in a lot of countries, especially also in Switzerland, there are laws around working hours, so you can't have people working on Sundays or late into the night. With an autonomous store, you can always stay open. And if you do have employees in a hybrid type setup, they can take more time for customer service versus just checking everybody out. Of course, you also get reduced staff costs with this. Technologies usually used, especially with Amazon Go, are computer vision, and also different types of sensors, not only vision-based system, also weight sensors and other types of sensors are involved. To know what we mean when we talk about autonomous stores, I'd like to take the analogy of self-driving cars, where there's quite a good classification of the different levels of autonomy. We're going from level 0, so no autonomy, you drive the car yourself, to level 5, that's complete automation, where the car can drive itself in every kind of situation. Now we're quite far away from level 5. Currently, people are playing with level 3 type systems and level 4, and hopefully level 4 should be well on its way in our lifetimes. Now, comparing this to autonomous stores, level 0 is the normal store, and level 5 is a perfect, fully automated checkout where nobody's ever able to steal anything. We're also very far away from that, so I will tell a little bit more about that later. Amazon Go would fall into the level 4 category. What they're going for is a fully automated checkout that works in most of the cases. Next slide, please. Thanks. So let's now talk about how you would build an autonomous store, how you could approach this problem from a technical perspective. First, let's specify, what do we need to know? We need to know who is shopping. So we need to connect people that are shopping with their account, or at least with a payment method. So let's say you swipe your credit card when you enter. We need to know who that credit card belongs to walking through the store, so we can later charge the items to that person. And that means we need to follow you around with the cameras, so we know then, second step, what are you doing? Are you grabbing an item? Are you putting it back? Are you maybe throwing it to your friend? Are you ripping open the package? Are you letting something fall on the floor? That's the second part. And then the third thing is, what is it? What's the product that you're interacting with? So we have this who grabs what, and that's all the information we need to then put the item in your basket or take it out of your basket, for example. What do we need to get this going? We need hardware, lots of it. Usually the most important thing is cameras. Most of the time you want to put them straight overhead because it's much easier to track a person if you have a camera pointing straight down than sideways. If you do something more advanced, you can also have it point sideways and track the person in perspective, but then you need to map it on the 2D floor map because you want to know in front of which shelf is this person standing right now. You might also want cameras on your shelves to see more up close what the person is interacting with. You might add some depth sensors like the Kinect, so you get a 3D approximation of what the person is doing. And you might also want to add weight sensors into the shelves, so you have another signal of exactly which product was picked up. And then lastly, all of this, of course, this video, this sensor input needs to be processed by compute. You can either add edge compute, so you can add co-located with every sensor like a camera, and then have a more centralized processing system with a little bit of less capacity, or you can have something central in the store or maybe even in the cloud. Now let's talk about the computer vision aspect of the setup. Let's say we've distributed a ton of cameras, some may be top-down, some may be sideways. What kind of models do you need to get this going? These 3 tasks that we've identified of who grabs what. And you can actually get quite far with just off-the-shelf models, even without retraining them. So let's say, those of you who might be interested in vision or ML, you might have tried YOLO. It's a really popular open source object detection library. And you can get quite good results even just with YOLO, because YOLO tells you where on the screen is this person, and then you just need to track them basically across cameras. If you want to go a bit more advanced, and the approach I would recommend to you, because you don't always have top-down cameras, you might have sideways cameras, and involve those, is to do pose estimation. For that, there's also a lot of really good open source frameworks, like OpenPose, for example. And then you get some extra info, not only just a blob, where is the person, you also get a location for the hands, which might help you when a person grabs into a shelf with the second task of grabbing. With grabbing, you need to know essentially what the hands are doing. That's going to be your most important use case. Most people are not grabbing food or items out of the shelf with their mouth, for example, with their teeth, especially not during COVID. So the usual use case is people grab it with their hands, so that's what we need to track. And then you can do a really simple classifier over video that takes into account the last couple of frames, so you know, is the hand moving towards the shelf, or is it moving away from the shelf? On the right side here in the middle with grabs, you see a screenshot of MediaPipe hands. That's a framework from Google that gives you even more info. It gives you the different fingers, and maybe that's useful for you to even detect a grabbing motion versus just position of the hands. And then the third task, what? That's really straightforward object detection task, for which you can also, again, use YOLO. Most likely you'll have to retrain it though, because YOLO doesn't have a ton of different products inside. That's kind of the most involved step in this whole situation. Or you go maybe even for a more advanced but harder to use network like ResNet. And there's also a couple of tricks that you need to apply here, because the state of the art in one-shot object detection, meaning you take a picture and you want to detect all the products in this one frame. The state of the art is 88 different types of objects you can detect with really good accuracy in this scenario. So that's definitely not enough for a store where you have thousands of products involved. So we need to do some tricks. You maybe need to use the hands to know, okay, I need to look closer to the hands, and then you can already cut the image. And then it's much easier if you don't need to find the product and classify it, rather just classify it. All right, let's say we did all of this and then look at an example problem. It's the most important one. It's called occlusion, the person standing in front of the camera. Even if you have multiple, they might just be blocking it on purpose even, or they are just by accident kind of blocking the view. How can we fix this? Because the best ML model can't help if you can't really see what's going on. We can add more cameras, or we could, for example, add weight sensors because they're not blocked by the view. How would we go about using those? The input from a weight sensor is usually quite messy. None of us really do a perfect grab in the sense that you go in, you really don't push down at all, and you pick it up very softly. None of us do that in real life. So it's more messy, and it's messier, and you need to figure out, was it a grab or was it a put back? Did somebody put back the product? That needs some machine learning or a different type of classifier maybe. And then you pair this with what's called in retail the planogram. For example, Migros in their challenge have a picture like this available for people to work with. It basically tells you where in the shelf which product stands. So you combine that with the weight sensor and you know a Coke 50 ml has been picked up. That's of course problematic because maybe there's a mess on the shelf, products are not in the right location, then you also don't know what's happening. Good. Now let's talk about a little secret in the industry. All the startups that are building these types of systems, they have a human in the loop. So none of these systems are perfect, and they never will be. We will most likely never achieve level 5 autonomy, because even with the human involved now, we don't have that. People still steal, and you don't know, you just can't see it. And what to do about it? So we're just, when we're not sure, we're taking a human and they're reviewing the footage. If we have footage of some direction, then the human can tell us, actually it was a Coke Zero and not a Coke Light. So that's what we're gonna do. And as I said, all the systems currently out there, even if they spend hundreds of millions on the technology like Amazon does, they still use this. That's why you get the receipt, the final receipt, not the moment you walk out, but rather a couple of minutes or maybe hours afterwards, so the humans have time to review. You see an example of the dashboard on the right-hand side. This is for cars. It's really hard to find screenshots that are specific for stores. Then this is the human going in and telling the system what actually happened. Now let's look at the full system design around this. We have this who grabs what scenario again, and we do the first decision, who, and maybe the system is not sure. It's going to give us a confidence level. Let's say if it's above 95% confidence, we send it over to the grabs system. If not, we let the human already review this part of the system and decide, was it this person or was it this person? And then it goes on with grabbing. Was it really a grab? Was it a putback? And then in the end, was it a Coke Zero or was it a Coke Light? And every time we're not sure what's happening, we're having the person review what was on the screen, what was on the video. All right, that was our overview over how you would build such an autonomous store. We're working on problems such as these and many more at Valora Digital, and we're also hiring for quite some positions, lots of software engineering, also designer positions, product manager, specifically machine learning, and also growth hackers. If you're interested in any of these positions, please feel free to get in touch directly with me. My email is up there. We also have a booth next to the entrance, and most of these, but not all of them, should be on our website, valora.digital. Thanks for listening, and let's open the floor for any questions. All right. In that case, if nobody has any questions, thanks so much again for listening. Don't forget to check out our booth and enjoy your lunch today and the rest of the hack. Best of luck. Thank you.
this really well. Actually, it does feel like we are actually competing in it, even though we are so far away.
You are competing in it.
I know, exactly. Feels strange saying that though.
Good. No, that's good to hear. And that's why we're having also this live pitch session, so we can actually hear what is happening beyond this building where I am right now. That's really cool to hear. Thank you so much for your contribution and share your impressions from your journey. Good luck.
Looking forward to showing the product tomorrow then.
Good luck. Thank you so much.
Thank you.
Bye bye. Okay, then I'm gonna go on with I see Daniel Simco just joined. Hi, Daniel.
Hi, Tanya. Thank you for the opportunity.
Thank you for joining. Tell me, where are you joining from?
From Zurich, we are here at Technopark.
Oh, you're at Technopark. Great, that's good too.
Yes.
Nice.
Yeah.
So pitch us your idea.
Yeah, so we are a team here in Zurich. 3 of us is working from here and 2 is remote, but they are also in Switzerland. And our idea is basically we do challenge 2, food for thought, and it's about bringing a solution to a user who is going to the restaurant or to a canteen to take a picture of the menus. And the result, what he gets, is the carbon footprint of each selection that he or she can make, and then just select out which one is the best for the environment. And we do this through the APIs from Eternity and Migros Gastronomy.
Okay, very cool. That was the the Q3 IBM challenge, right?
Exactly, number 2.
Okay. And I actually met someone yesterday who was looking still for a team to join Food for Thought. It was a lady, I don't know if she ended up joining your team.
No, we already found someone yesterday, right before the beginning of the whole event, and he's already sitting next to me and doing the UX part. So yes, we managed it.
Okay, great. Yes?
There are still people looking for teams, or?
Oh no, I mean that was yesterday, so I don't know
Okay.
actually. It might be.
Okay, and how was your interview with Ross?
Good. It's actually online on YouTube right now. It's just a short statement that you can check it out on HackZurich YouTube channel for everyone who hasn't checked it out. We have some additional material there. But Daniel, tell me, what are the challenges that you're facing so far that you're trying to fix until tomorrow?
The challenge is right now, maybe the biggest one is that we want to achieve more than the time frame is enough for, but we are proceeding quite well. And right now, the biggest challenge is maybe to connect to APIs, so it's in the development part.
Okay. And is this something, the whole thing that you said with the reducing the CO2 carbon footprint by knowing what you're eating, is that something that your team has already been working on before, or was it challenges because you saw it here that you took it?
The whole project started that one of our teammates was interested in the topic. He started the DevPost project, and actually we joined him because we found it interesting. And he already knew something about the 2 APIs that we use, but in general, we started the development only here at the Hackathon Zurich. And we put together the whole idea and the whole application idea here.
Okay, cool. Well, and good luck to you. All the best for the last few hours to go.
Yeah. Thank you very much, Tanya.
Bye-bye.
Goodbye.
Okay. Oh, and then, yeah, you just saw our cameraman. He just disappeared. So we're doing some behind-the-scenes footage as well for social media. You can actually have a look. Hi. Okay, William. I'm gonna add William to the stream. Hi, William.
Hi. Yes, that's correct.
What time is it there right now?
It's almost 9 o'clock at night, actually.
Okay,
So
okay.
I'll be. No, it's not too bad, but I think I'll be going until somewhere around 4 a.m. in the morning.
Okay, so
Because we also have team members in Central European Standard Time and also in Argentina. So
wow.
we're spread out. We're spread out all across the world, and it's been fun. But we've all had enough sleep, which is good.
That's an achievement, I would say, during a
Yes,
hackathon.
it is a big achievement, actually.
How many team members are you?
Yes, well, it seems as if we're currently down to 3. We did have 5, but I'm not sure where the others have gone. But still, it's been working quite nicely.
Okay.
Yeah.
Did you disappear or what?
Yes, basically.
Okay, so shout out to them, maybe get in touch with William. But yeah, you seem not too desperate, so seems to be fine with 3.
Yes, it's been working quite well, actually.
Okay, so I'm gonna give you the floor. You can pitch your idea, what you're working on, what problem you're trying to solve. Okay.
Yes, so we actually wrote a bit of a pitch, and it's going to be fun. So, so I have a problem. So for the last 6 months, I've been sitting, working at home, ordering Uber Eats for every single meal. And I've been having the same pad thai every single day for every lunch. But, I'm sitting here, I'm looking at pictures of sunny beaches and coconuts on my Instagram feed. What if I could experience that moment just by walking down the street? So, introducing our app, which is called Pick Up Bar. Very funny. Now, I can not only enjoy a delicious meal, but I can also help save the planet. So every time I walk or bike to pick up my order instead of getting delivery, I reduce my carbon emissions. I even get a discount on my Zurich health insurance or Zurich Live Well partners for doing the exercise. And even if I do get delivery, Pick Up Bar allows me to offset my emissions with Climeworks. So it's a win-win. And soon, in the very near future, I'll not only be able to get recommendations for the most tasty dish, but I'll also be told how sustainable those dishes are. So here we've got a global team of developers, as you've just heard, spread across 3 continents. So what are you waiting for? Register today, invest in you now, and save tomorrow. Yeah.
Very nice. Okay, wow, that was a pitch. So how did you guys come up with the idea? What inspired you?
So we actually had to take a look at all the APIs, as in we made sure that our ideas were very flexible at the very beginning until the workshops. And at the Zurich workshop, they wanted something relevant to insurance. Now, linking climate change with insurance is a bit difficult. So one way of linking it is by saying, well, if you walk instead of getting delivery by motorcycle, then you not only benefit your health, but also you benefit the planet.
Cool. Nice. And what are the challenges that you still face until? I mean, you said you got enough sleep, so it seems like you're not facing too many problems.
Yes, things are going reasonably well. Obviously, I'll be staying up very late tonight. But I suppose about 10 to 12 hours of programming time is about right. So hopefully we'll be finished by the end of the day, your time, basically.
You mean today? So you can...
As in 9 p.m. CEST, so that we can get some sleep as well.
Before the decision, you mean?
Yes, as in we hopefully will be finished like 12 hours before submission, basically.
Wow.
Yeah, that's the plan.
Okay, cool. And as I have you on, how is it for you to join the hackathon remotely? I think Vishnu mentioned, he still felt like he was part of a team. I mean, you're on the other side of the world.
Yes, well, I've done remote work before, so I've used Microsoft Teams. I'm sure everyone else on my team is either working from home or studying from home. So it's actually quite normal for us. We've been doing it for 6 months.
Okay, so you're just used to it.
Yeah.
Great, William. Well, thank much for joining. And I don't know, is there any behind the scenes image we can see from you that you posted maybe somewhere?
No, not really. I could post some, or we could post some
If you
of our
want.
Zoom.
It's always nice to see.
Yes, of our Hangouts chat. It's actually going really well.
Yeah, send us that. Okay.
Yeah, great.
Well, William, then good luck with for you as well, and all the best.
Sure, thanks.
Thank you for pitching.
Thanks, bye.
Bye-bye. Okay, well, it seems that I see that there's still someone connected here, but somehow the device is not connected. So therefore, as I don't see anyone else in the virtual studio to join, I think I would close this session for today, or for now. Thank you so much for listening. And if there are people that still feel I would have loved to share my idea and pitched, then maybe just DM me on Slack. And let's see if we have enough. Maybe we can organize another live pitching session. I wish all the teams all the best, and check out the HackZurich social media channels. Goodbye.
Good. Hello. My name is Oliver Sanchi.
And my name is Florian Bergi.
We are from the Federal Office of Information and Technology called FOITT. For those who speak German, it's maybe a bit easier. The short term is BIT. So, first, we're going to talk about EETS. First, I would like you to show briefly what EETS is all about. EETS stands for European Electronic Toll Service, and it's all about trucks, or specifically about foreign trucks driving on Swiss roads, because every truck has to pay a tax when he drives through Switzerland. We are trying to prevent this. Okay, the picture is maybe a bit too extreme, but until now, every truck has to stop at the border and manually get a ticket. He drives through Switzerland, comes when he leaves Switzerland, he has to stop again and pay the fee based on his distance and the weight and so on. So with EETS, we try to stop. With EETS, these stops are no longer necessary and the whole billing process is done automatically. So how does this new system works? Here we see a schematic illustration of Switzerland. Maybe I show you. It's a bit dark. This is Switzerland. Outside, for example, Germany. Here, Italy or France. There are logistic companies which own trucks, 1 or maybe 100. There are companies specialized for each provider. This is a special term which you will hear later on. So they have a contract with these different logistic companies. The Federal Customs Administration is actually our customer. We developed this system for the Federal Customs Administration. They have contracts with each provider. There are maybe 5 till 6 providers in this system. So, on each truck, here the truck, there is a special hardware device called onboard unit. This onboard unit records GPS tracks, communicates with the EETS provider over the air, over mobile data, and can communicate with these control stations. With this information, our system can verify if the GPS tracks correspondence to the reality. So, these control stations. They are at the border of Switzerland and inside Switzerland. And that's how they look like. When the truck passes, here is the truck, it's a bit fast, they communicate, and then we know exactly at which time, which truck, at which position drove through. So, now a little animation. It's a bit difficult, so, I missed it. Go. It's not working. Anyway, we leave that. The animation is just that this little truck drives here through Switzerland. The most important part is that the truck always records his GPS data and sends them permanently to the EETS provider. And at the end of the journey, the EETS provider sends us all the data for our system. So how we built it, that's the next slide, is a different view of the approach we built it. So we have here in the center the EETS system with the surrounding systems we are communicating. Here is the EETS provider again. Here are the control stations. It's called also roadside equipment. And here is the billing system, SAP. The EETS provider sends us specific information about each truck. It's called contract. EETS passes this information to the control stations so that they know when the trucks arrive and can identify this truck. So when there is a passage detected, this passage is sent back to EETS. After, maybe in the night, when the truck drove outside, exit Switzerland, we receive a declaration. In this declaration, it's basically the GPS informations where he drove through, but for the whole journey, not only inside Switzerland, so we maybe receive a GPS track from Hamburg to Milano, and then we have to detect how many kilometers inside Switzerland he has to pay. And that's a bit tricky, but later on we see that. And after a while, when we calculated the price for this journey, the price depends on the weight of the truck and emission class and the distance. So we can assess this, make an assessment. That's like a little bill. But at the end of the month, for example, or after 20 days, we make the whole invoice billing, and there goes a payment, I don't know the word, Einzahlungsschein, to the EETS providers. So, this talk is a bit about microservices. Of course, I want to show you how we divided our system into different microservices. Every microservice has its own context. For example, the provider interface service here, his purpose is only to communicate with the provider, with the EETS provider. Nothing more. We have here the declaration service. This service calculates the distance traveled in Switzerland, has mainly focus is GPS data and so on. The plausibility service, he checks if the track matches with the measured points from the roadside equipment, from the control station. If that makes sense, we detect that here. And if everything works automatically and no discrepancy is detected, we go on with this assessment. This assessment service makes the real calculation about the price, and then at the end, billing goes out, makes the bill. In our case, all the backend services are written in Java based on Spring Boot. For our user interfaces, we have a few, it's not on this image. We use Angular. And the most important prerequisite for running such a microservice-based architecture is a platform as a service. In our case, we use Cloud Foundry. So how the microservices talk to each other? It depends. For example, when there is a user interface, the user interface talks with the backend service via REST API, HTTP. That's nothing new. Also, but the But the nature of our business is highly event-driven. So a truck drove through Switzerland, we receive something, and we have to calculate something, and we don't know when and where. Where not, but we don't know when to do that. That leads us to the event-driven architecture. And here is an example how this works. For example, we have our assessment service here. As I said before, this assessment service calculates the price of a trip based on the input parameters like distance, weight, and emission class. So something comes into the service, maybe also over an event, and the assessment service calculates this and then sends an event to somewhere. This event is maybe called an assessment created event. The wording is always what happened in the past. And for the assessment service, the work is done. End of story. He does not have to know who's interested in this event. He does not know who is subscribing to this event. He just calculates and sends something. And of course, this message or this event must not be lost. For this, we have a message broker infrastructure. It's here called as a broker. In our case, we use RabbitMQ, but also we could use Kafka or something else. We use actually RabbitMQ. And it's like the next step is these services are interested in this assessment created event because the billing service has to do something and the provider service to do something else. I don't know what, but they are interested. So they subscribe themselves to this broker. With this, the broker knows now which event, where he has to send the events, and he ensures that the event is delivered at least once. That's very important for our system. So we have to take care of this infrastructure of this RabbitMQ cluster. Okay. And when the provider interface or the billing service has time, they listen on this queue, and when they have time, they can consume this event. Mostly it's nearly real time, but maybe if there is a big queue, they have to wait a little bit. So that's all the secret about event-driven, and everything together gives us this picture. We have our three cornerstones of the architecture, like microservices, event-driven, and the platform as a service. And with these 3 points, we achieved some goals through this architecture, which gave us a lot of pain in the past, before microservice architecture. For example, the complexity. We can cut now the complexity into different deployable units. That means we don't have a big application which is too complicated for the developers or for the maintainers when they're later in production and there is a bug. They can focus on one topic. We can scale. That's very interesting because when we can scale specifically. That means if one specific microservice is on its limit, we can create more instances of this service, but not for the rest of the application. Just an administration service has to have 4 instances. But for example, the provider interface service who has a lot of needs a lot of power, we can scale that. And this is one click in our environment, nothing more, or we can do it automatically. We have zero downtime deployments. It's also interesting for the customer itself. When we have a new version of this of a specific microservice, we can deploy that, and no one sees anything. It's just there is no downtime. How that works, you can come to us, and you can ask me. Yeah, exactly. Okay. Also the big advantage is, I don't know if I told you that we don't have to get up at the night or at the weekends to do deployments. The deployments are quite easy. We can always do that during the week, and because we do it often, there is no pain anymore. Before, we had deployments once a year and big panic everywhere, but now we can just say, next week deployment, okay. Mostly he is looking for that, and everything is fine. Okay. Where we are now, I give the microphone, or I give this to you.
All right, so what we're going to do is we're going to take a closer look at the GPS analysis we're doing. So as Oli already mentioned, we are receiving millions of GPS points for trucks driving through Switzerland every day. So it is important for us to be able to analyze them correctly and in an efficient manner. First of all, I want to give you an impression on how that could look. So that's a view on a map from a journey throughout Switzerland. This journey is about 4,000 GPS points long, and this allows us to calculate the distance to a certain extent of narrative, or to a certain, just to a certain limit of deprivation from the actual trip. The little green dots you see are crossings with border stations, so where the truck entered and left the Swiss border. But if you do that, there's always some kind of challenge, because really the only data we have is the GPS track. And there is a standard defining all that data transmission, so it's the same all over Europe. And it defines that for each day, there has to be a separate declaration. So what that might lead to is that there are several trip parts for the same vehicle, and we don't really know if they are supposed to be matched together or not. So in order to check for that, we of course look at the vehicle identification, but then there is also time gaps, distance between start and end points of tracks, and all that. And of course, there is another big problem with us not recognizing entries or exits properly, because GPS data might get interrupted, or the provider might just send us too short of a overlap, let's call it. And imagine this case if the red dot is just one transaction from our control system. And it's hard for us to know if there was an entry or an exit. If we look at it now as humans, it becomes pretty clear. There was an entry and an exit. So what we had to do for that is just define multiple borders, like an inner border and an outer border, and then the actual border, to just detect the direction a truck passed the border and stuff like that. But that was quite an interesting challenge, in my opinion. So, of course, if you do GPS analysis, there are certain pitfalls, like going through tunnels or, as I mentioned, missing border stations, and also the question of how close to the actual journey or the actual distance we can calculate the distance based on GPS data. That involves quite some interesting math. All right, the next thing I want to talk about really quickly is quality assurance, because as Ollie mentioned, it's kind of important if we deploy maybe once a week or even once a day that we have a stable setup for quality assurance. The first thing I would like to point out to you is consumer-driven contract testing. This is a concept that allows us to verify API compatibility between services without starting them up two at a time. So we can just do that at unit test time or compile time. If you're interested on how that works, hit me up. Of course, we do some boring or standard business process testing where we just run through the most important business processes for our service. For that, we use Selenium for UI automation, then JUnit and some other frameworks for the actual test execution and some REST calls. And to scale that, we run it on a Docker-based environment. The last thing I want to talk about is end-user integration. As you can imagine, if your business partner is a big corporation, they are really interested in having that integration done early and done properly. So what we decided to do is we were going to provide them a Docker-based setup where they can just run one of our production services with no visible difference, and then a service that mocks sort of all of the rest of our services in order to have a system that reacts exactly the same as our production environment, but they can run it whenever they like, wherever they like, and how often they would like to do it. Also, we have provided them with an API to just set up data for certain business cases they might be interested in.
That's all.
All right, so that's all. If you have any other questions, hit us up. Yeah, there are our infos. So the virtual hunt, which I am partially responsible for, is currently not running, but we're working on getting that fixed as soon as possible.
Are there any questions? Maybe, I don't know how much time we have. Okay, 7 questions.
All right, so maybe if you have a question, ask it. Otherwise, we'll just tell a little fun fact that we figured out. So when I started kindergarten very early on, way, way back, he started working for our current employer. And yeah, we're still happy to be here together, so that seems kind of fun.
That means I'm old.
That's one way to put it.
Okay, thank you.
Hey everyone, thanks for coming. So I'll talk a bit about our work in Berlin, what we do at Merantix. Actually, it will be two of us presenting, so I'll give a very brief introduction, talk a bit about Merantix and our ventures we've been building in the last couple of years, and then I'll hand over to Thomas, who heads engineering at Merantix Labs, our solutions provider, and we'll talk about some of the more technical learnings and also challenges we have when bringing machine learning into the real world. So who are we? So we are a venture studio that builds AI-first companies. So we incubate companies that have a very strong machine learning component, try building the teams, make sure they basically cover all the interdisciplinary skills we need in order to become a successful company. We finance those companies and then basically help them to grow for the first couple of years and build their first product and bring that to the market. And we've been doing this for around 4 years. We've been starting a few companies in very different spaces, so in healthcare, automotive, and some other industries we are venturing into right now. So it's pretty broad, but the common theme is machine learning, and actually all our companies are under one roof, so they're all located in the same office. We are even building now a larger AI campus where we also will integrate some external companies, so we'll have space for around 500 people that will all work on the topic of AI under one roof in Berlin. It's going to be the AI campus we're going to open up in March next year. And so there's quite some collaboration between those different ventures, even though they end up being independent companies legally and also in terms of the setup. And so, yeah, we've been working on a few different companies. So the first one we started was Valora. It's a company in the space of medical imaging, specifically breast cancer screening. So we basically help radiologists who do breast cancer screening, which is a very deadly cancer, to make much less mistakes. Right now, around 25% of the cancers are missed, but also to make their work more efficient. And so there, we've brought a medical product to the market, Valora. You can see in the background that basically helps radiologists in this journey with a very nice UI, but also with algorithms in the background that help doing parts of the diagnosis. This product has been certified. We've trained as a medical product. We've trained it on a few million medical images from around 20 medical institutions all over Europe, and so now it's really about making the algorithms even more robust, but also ultimately venturing into other areas of medical imaging beyond breast cancer. And yeah, this is already in production. Quite a few screening centers are already using it. We have a second application, second company, CEST, that is in the space of data management. So you can imagine when you have petabyte scale of sensor data, specifically from cameras, but also other sensors, it starts to become quite hard to manage those data. So we work, for example, with some of the large car manufacturers, which end up having petabytes of image data from their cars, which they use for autonomous driving or also more assisted driving functionality. And so once you have a few petabytes, it starts to get quite hard to figure out what data you keep, what you want to throw away, and also even just search the data ultimately to improve your algorithms and also validate them. And so CEST basically analyzes all this data, adds a lot of metadata to it, and then allows the customers to efficiently manage that data. Then we have Merantix Labs, that's what Thomas also will talk about a bit more in detail later, where we work specifically for corporates, but also smaller Mittelstand companies on building specific AI solutions for them. So there we start sometimes quite early in the process, work with those companies, help them also identify use cases, but then also build production-ready machine learning systems. We have 2 new companies we just incubated a few weeks ago. We started working on them at the beginning of this year. One is Cambrium. They're in the space of biomaterials, so basically using machine learning to produce novel biomaterials that have novel properties. That's a very interesting space because you can imagine now with sequencing costs going down and also more lab automation, there's quite a lot of data in the space of biology, and that is obviously then a great playground also for machine learning applications. Second company, Causa, is in the space of explaining KPI changes. So what we do there is basically trying to explain when a KPI changes, why this has happened. So you can imagine when you run a business and you have some KPI, I don't know, revenue you care about, and suddenly the revenue goes down. Usually you go to your business intelligence team. They will work for a few days, then try to come back with an explanation why your KPI has changed. and then you basically take actions upon that. And so with Causa, we basically try to automate that process to some extent and directly give back hypotheses around why the KPI could have changed. And so this goes partially also in the space of causal inference, where you also try to start inferring causality. So it's also pretty interesting. Those two companies are pretty new, still early, but yeah, we'll probably be able to show more in a couple of months. We have two new spaces we're looking into. So we're looking into some venture case in the space of reproductive health, so fertility, and a second one in the space of non-financial risk monitoring. So basically monitoring organizations from the outside using social media data, but also some other interesting data sources. So just to give you that as an overview, we are, as I said, pretty broad in terms of industrial applications. By now we are a team of around 80 people, obviously very, very heavy on the technical side, but also quite a few business people and also founders. So as I said before, like our main business model is incubation. We build new companies, and so we are also always looking for people who want to start a new company with us, with a heavy machine learning component. So yeah, if you're interested in that, if you want to come to Berlin, please let me know. I mean, I'm obviously around for the rest of the hackathon. So yeah, just grab me after the talk. And with this, I'd like to hand over, and also reach out to me if you have any questions, also something which is maybe not directly related to Merantix. And with that, I'd like to hand over to Thomas, who will talk a bit about labs and some of the more technical challenges we have.
Thank you for the kind introduction, Rasmus. Thank you for joining this tech talk. So I'm from Merantix Labs and leading the technical team. And in a nutshell, we are your external machine learning department. So what we do is we guide our clients from an idea how an AI could improve their business to the actual AI into production. And we start with ideating with our clients their ideas in workshops and propose a roadmap how they can use AI into production. Then we start building proof of concepts with them, showing them what is actually feasible, and finally test if these solutions actually have an impact on the business value, and then in some cases also build corporate ventures. So today I want to share with you some learnings that we had in the past years, which you probably already heard of, but I want to emphasize them again, since in practice they are very frequent and really have a high impact on your machine learning project in production, and are very different from which challenges you face in academia. So first of all, you have to keep your sanity. Why? Because of reproducibility. Actually, you try to build a pipeline, try to make it as reproducible as possible, then you run it again at some point after you did some modifications and it does something weird. Then you go back, try to replicate your first result, you can't replicate it. And this is pretty frequent. And this has a few causes. First of all, you should versionize everything that you have in your pipeline, like data, your infrastructure, your models, your configuration, seeds for random number generators, everything. And you also do some design choices here, from like full snapshots of your data over diffs between data, or just keeping the configurations to generate downstream data. And this is kind of a trade-off you have to make for reproducibility, how fast you can check if your pipeline is actually reproducible. But some, and you can control these factors, but some you can't control, and these are very hard to observe. For example, in one use case, we run our pipeline and got results from a server, and then we run it again, and our pipeline didn't work anymore. What we observed after a while, that there's something in the network intercepting our connection and altering our data, and you can't control this, but you have to figure that out. You have thought you controlled everything, everything is reproducible, but it isn't. So test if your pipeline is really reproducible and not just think that you did everything correctly. Moreover, real-world data is really misleading. And that's why you have to know your data. So I want to show you a few examples what can happen in practice which really makes your job hard. First of all, class imbalance. Academic data sets are nice. You either have a balanced data set or it is well known how to cope with imbalance in your academic data. In the real world, this is different. You don't know the data set. Most of the time, they're very imbalanced. You have very long tail distributions where you have a lot of samples for one class, but just a few for others. So you have to use techniques to cope with that, resampling, finding hidden hierarchies in the data, and so on to cope with this challenge. Moreover, there are other challenges like hard samples. So in this use case, you have mitotic cells, so cells that are dividing in histopathology images, but at the same time, you also have apoptotic cells, so cells that are dying. And they look very alike on the images. To differentiate them with your model, you have to do something like hard negative mining and balance of your loss function to cope with that. But first you have to know that you actually have this problem in your data. Then there's another challenge with this data set, which is domain shift. You get data from a new microscope or just another person who prepared the slides, and now they are much more pinkish. And this is also a real challenge for your algorithm, so you have to cope with that as well, with normalizing the data, making your model invariant to these changes. And to do that, you should know these challenges in advance. And that's why you should always ask for data samples. Get them as early as possible. You will quickly see that this is probably not a sample that is representative to your problem, has specific data points missing that are important to solve the task, and you have to iterate to get an idea what are the actual challenges to design a solution. So you should go as early as possible to ask for data samples. And this also comes with doing no assumptions, because if you get your first data sample, or even before you get a data sample, you do assumptions of how the data might look like in production. But this can be completely different, so try to figure out what are the differences between what data samples you can get and what is actually running in production. And to do so, you should build a common understanding of the data in easy language, communicate with the creators, but also the creators of the data, but also the users of your AI system, so you understand the training data and the differences to the data in production, so you can cope with all these challenges that arise in your project and not misunderstand the actual problem and solve some more academic problem that is not useful in practice. What we also observed in practice a lot is that our customers have a lot of data, but they don't have labels. Or sometimes they don't even know what classes they are looking for. So what we came up is a solution where we build an embedding for each data sample which is not labeled, and then the user can explore this data set. In this example, we have a couple of product reviews, and first of all, you see some clustering based on some language model, and then the user starts to link specific reviews together and say, yeah, these are very similar. And then after a while, clusters arise, and these clusters then can be used as labels to train a supervised model. And with this, you have the discovery of classes, but at the same time also have a tool for labeling your data set. Moreover, industry doesn't like black boxes. Nowadays, algorithms have a problem with explaining of how exactly they come to a decision, but still, you should go for providing some explainability. What is the actual root cause, especially for humans to review the decision of the machine, so they can do their own reasoning behind it. So here you can see an example of some cast iron piece, and your classifier says, yeah, this is a defect piece, but it's not very obvious where's the defect. But with using one of these techniques for getting a spatial map, which pixels are important to actually perform the classification, the human gets a guidance how the decision is formed and can make their own decision about this image. Moreover, what is also important are adaptable structures. So if we look at a software project from a bird's eye view, you have your hardware, which is running your software, and then you have the organization of your team around it. And hardware and software in the field of AI is changing very quickly. So every year, new GPU generation, every couple of months, a new framework which solves some tasks which haven't been solved before. And your organization should cope with that. So be very flexible with your structures, workflows, how you can move from one tool to another, which is pretty important to not get stuck with one tech stack in your company. And what also happened, I think, to everybody who started with machine learning in like 2015, that you built stuff for more abstract training of your models, which you can now do like with Keras or PyTorch Lightning or whatever. You built your own hyperparameter optimizer. Now there are lots of libraries for that. You built something for parameter management and so forth, for data management. And after a while, you figure out, hey, some open source alternative arised, and there are lots of people behind it who already built most of the features that you actually need. And then is the time to overcome the not invented here syndrome and move to these solutions and contribute to them, which is very important to keep up to date, because these solutions, they have much more developers than you can have in your small company. What is always important when you do that, avoid some vendor lock. So always have an exit strategy, how to get away from these solutions from the beginning. There are multiple techniques for that, like wrapping these solutions, having standardized data formats, or and much more, like from standard software engineering. And as I said, also the organization has to be flexible to move to a new tech stack. What is also very important is have a proper infrastructure. So the machine learning code is actually just a very small piece in a whole set of infrastructure components that are important to bring AI into production. And what really helped us is, first of all, put your best practices into code. Why? Nobody likes reading long documents with guidelines for your style, for how to structure your project, how to manage data. And in your workflows, there are lots of tasks which can be automated. So make tools for that. Even if you can't automate everything, having a tool which guides you through the process and is fun to use is more accepted than just providing a long guideline. And if somebody has a proposal how to improve the process, they can just do a PR to the tool, it gets reviewed, and then you updated your process in your company, which is pretty neat. Moreover, what is already pretty standard is using infrastructure as code. It helps you with the reproducibility and maintainability and traceability of your pipelines. And what is very important here, that the data scientists can spin up the infrastructure themselves. They don't want to wait for some DevOps to spin up the infrastructure and provision it and everything and manage it, because this takes time. In the meanwhile, they did their own setup, which is maybe not that powerful, but they did it somehow. So the role of the DevOps changes in giving good tooling to the data scientists so they can spin up their own infrastructure on their own, at least for developing the AI. So production is different, but for the development, you want to enable the data scientists to play around with their stuff as much as possible. What also was very important for us to introduce project templates. So this really helps getting into a new project, because you're already familiar with the structure of the project, but you can also use it as a tool in addition to libraries and modules to preserve learnings from projects in the past. And how could such a infrastructure for development of an AI solution for an engineer could look like? So the developer or the data scientist has some machine, some laptop, for example, not a lot of compute. They use some versioning to manage the code. Then you have some cloud provider. We use a lot of Google Cloud in our company. And then you have your continuous integration server like Cloud Build, and this provides images of your current code to some container registry. You also have some cloud storage for data, for your models, and so on. And then the developer has some cluster on hand to run the models, can save different experiments, and communicate with the registry and the models and artifacts, and in the end also deploy the models in that cluster. And all these infrastructure should be spin up by the developer themselves and also tiered down by the developer itself, so they are enabled to manage their own environment. What is also important to have infrastructure to monitor your model into production, because what you're actually optimizing usually with your models is not the business goal of your customer. These are two separated things. So if you have a model that is very good at predicting the market behavior, this is not necessarily coupled to the profit or loss of your client. Or if you have a task in quality assurance or in medicine, having a model which is very good at classifying a specific tumor, for example, is maybe nice from an academic point of view, but from a physician point of view, they want to have a system which is perfect and you also can account. And therefore, maybe a solution based on smart elimination makes more sense, because then you can process the complicated cases by a human, and the easy cases are pre-processed already by your AI system. And to figure out what is actually the business goal and the impact that your model provides to solve that business goal is important. So log everything you can do, especially when you first deploy your model, visualize, try to figure out what's the actual impact of your model, since it's so different from like your lab environment where you developed your AI. And also have an eye for data management. So nowadays, lots of the data that is collected is unstructured and never used again. So, for example, in the automotive sector, you have all these sensor data like cameras, and you have a lot of information in there. Like there are bicyclists driving, you have some traffic lights, different events, lightning condition, weather, whatever, but all of this is hidden in the video and you don't have structured information. And what car manufacturers do is they annotate all these data manually. This is a lot of data curation, selection, aggregation, until they get to some data set that is useful to train some model for autonomous driving, for example. And what one of our Merantix companies, Search, is doing is providing a platform to ease that process. So you can use heuristics for filters, and you can use machine learning to annotate all these sensor data, provide a needy API and a querying language to search in that data, and also a usable, so usability-friendly UI. So you can finally focus on what is important. You don't want to like mess with these petabytes of data. You want to focus on solving the actual mobility problems, and with that solution, it's much easier. And this was just a learning from one of our early days, where you first try to solve autonomous driving, and then you see, oh, like this sector has a completely different problem, which is all their unstructured data. So to sum up, the learnings I have for you today is keep the sanity by really testing if your models or pipelines are reproducible, and real-world data is misleading. Know your data. Industry doesn't like black boxes, so try to find some methods to give some explainability. Have good adaptable structures in your organization to cope with this fast pace in the tech stack changes. Also take care of your infrastructure to enable your data scientists to build and also deploy your models, and have an eye for data management, because you have so many unstructured data which is not used but could be very useful for your AI solutions. So if you are interested in one of these topics, so just reach out to us, and I'm happy to take some questions now. I see no hands. So if there are no questions, then thank you for your attention and have a nice hack. Thank you.
presentation about perfecting your pitch, and in that sense, hopefully to maximize your chance to win this hackathon here at Zurich. Now, in the next 20-25 minutes, I try to give you a few hints that you can hopefully then use practically, either when you submit your demo, your video tomorrow, or on the other hand, then hopefully when you're in the final round, and to consider what do you need towards the main jury to be successful. Maybe to start with, quickly, I'm an associate partner at McKinsey. I'm always saying I'm now a consultant by profession, but actually I'm a computer engineer, or by passion more a computer or a software engineer. So I was at some time also at the hackathons. Hopefully I can give you now a few more hints of what makes the submission successful in the end. So a pitch is typically structured in 5, maybe with a few more elements. You start with a key message. This is your one statement of how you sell your project, your solution. You go then, what is your problem that you solve? The solution or a secret sauce? What makes you special? Why is it your piece? And then, I think in this case, you go to quickly introduce the team, and then you come to the product demo. I think especially in such a situation here, use time for the product demo. So key is the opening, your message, and then in the end, the product demo that you can sell it. You may have a clear problem that you solve on the market, explain the business model of it, explain the market size, explain the go-to-market if you have it. I think this environment, it's not fully required. Now, or let's say like that, this is the standard way of how you can pitch stuff. There are other ways, this is typically how it works. I think the key element for you guys is now, how do you stand out of the crowd? When the jury, when the people who are reviewing your submission, they will spend 2, 3, maybe 4 minutes, if you're lucky, to look at the video, to look at your solution that you have. How can you make it special so that people think, yes, this is the greatest thing? And we typically say there are 3 ingredients that can help you. One is to structure the communication to make it easy to follow. The other one is then tell a story. Tell something that people can remember. Get personal in that sense, that they feel it. And the last thing is your personal credibility. How do you stand up on the stage? How do you talk in the video about your product that you know, the jury knows, this is the team we want to select? Now, if we go through the different elements, I will quickly explain a few hints to each of these pieces. I start with structured communication. And let me actually start with an example, as I think it's typically easier to understand what we mean with that. So if you ask the audience of your presentation, of your pitch, to remember these 9 items, I think it's pretty clear this is, at least for me, very, very difficult, as I'm not that good in remembering things. But if you look at it in a second stage, you could actually group them. So for instance, you can bring together yogurt, butter, milk as one of the pieces, and you can do this similar with the rest of it. And then you get to kind of a pyramid. And if you start talking like that, people can remember that. So you start, hey, you need to do your grocery, and I know this is actually the next thing I have to do after my presentation here. You then get 3 categories: diaries, grocery, and drugstore product. So this is a way I can remember the stuff, and your audience also can remember. Because the main message you give them is, don't forget to do the shopping. And afterwards, they start to remember the things that are there, and not the 9 individual elements that at least I cannot remember. Now, we call this the pyramid principle, and I think, for me at least, this is one of the most effective ways of how I can typically tell a certain story, of how I can tell a certain message. You start with a key message: why, what, how, and I will show in a second a few examples of how such a key message could look like for a few of rather well-known products. And then you go deep. What is your message? You explain what are the supporting statements for each of the element, for your problem, for your solution, and for your product in the end. Key message first, and then supporting statements. Now, the first message. How do you initially pitch 10, 15 seconds your product? 3 examples. Airbnb, book unique homes, and experience a city like a local. This is their start message. In almost all of their talks, in almost all of their pitches when they started. This is the message they want to give. And then they explain why their platform is the unique solution for that. And I think we all believe nowadays that they do pretty good in that. Canva is a graphic software. I think it's not that exciting if I look at the statement. Amazing, simple graphic design software, but at least it tells to the point what they want to sell. And finally, Slack, which we're all using as the most important tool, I think, today, on a mission to make your working life simpler, more pleasant, and more productive. And if you have this statement, if your jury remembers this statement, you win. This is what they should remember. This is the reasons why they should keep attention. It's the first 10 seconds, and they decide, do they go into a sleep mode afterwards and just listen to you somewhere in the background, or are they keeping attention when you pitch your stuff for the rest of 2 minutes? So, first piece, structured communication make ideas easy to follow. One thing. The second thing is storytelling. Tell a story that people have an easy way to follow your ideas. What does that mean? This is an example of how you could structure a story about the customer journey. There are different ways. But I think this one is typically, if you have a customer-focused product, a pretty good way. You start again with the statement that you had before seen, then you go into, why is this a problem? Why are the existing solutions insufficient? What is your solution? What does your solution address? Or how do they address the problem? And in the end, why is it better than the existing solutions? But you have a clear structure. You have a structure that everybody can follow when they listen to you. It's no jumps, it's a flow. And I think the key element then behind the story is simplicity. And I really like the statement of Albert Einstein at that time, if you can't explain it simple, you don't understand it well enough. And to make it simple to understand it, we are back to the topic, you need to repeat stuff, you need to learn stuff, you need to rehearsal stuff, that you can present it to somebody. Now, you have a wonderful structure, you have a wonderful story to tell, you believe this is the greatest thing, then I tell you, keep attention for 3 C's that make your style, that make your story more compelling and easier to follow then. We talk about, is it clear, is it concise, and is it compelling? What do we mean with that? I think clear means you use verbs that are in active mode. Don't use the complicated passive sentences, very difficult for people to follow. Verb and subject always close together. Helps. These are the 2 elements of a sentence that are important. Tell them together and not a verb, and then half a minute later you tell the subject. And finally, simple, plain words. You will talk to an audience which is not always fluent in English. You talk in an audience that may not keep super attention to the stuff. And the more complicated the words are, the more complicated the sentence are, they cannot follow that. Second, concise. Short, strong words. It's words that you highlight that will keep again the attention of the audience. Repeat the words and don't use any unnecessary words, modifiers, or whatever. Don't use the not statements there. Make them clear. Everybody repeatable. Then the last thing is compelling. Metaphors connect people. Again, it's a story that you're telling. If a metaphor is there, this is way easier to follow than anything else. Pictures are the best way to explain this thing. And if pictures are not possible, image-based words are even better and explain the stuff to people to remember the stuff. So, storyline, and then the last piece after the storyline is the personal credibility, which I think is in the end the foundation. And I said it's in one way, it's on the video. When you submit the video, it's your voice that the people hear. And then during the final pitch, it's basically you on the stage or you on the video that people are looking for. 4 elements to this one. I think 1, practice, audience, energy, and choose your rules. Let's start with the audience. I think about who do you talk to? How can you address this audience? How can you be in front of this audience and explain the stuff? It's also about basically using the right words, it's using your hands, it's using having a clear statement in front of here. Then the second thing, and now I'm jumping, is choose rules. It's very simple. You always know it should be one person at one time on the stage. Yes, it sounds very easy in theory. Practically, there is the second person next to you who would like to say something as well, and then it starts to be more complicated. Who is doing the demo? Is the person doing the demo speaking, or is the other person speaking? Define that. Think about that in advance, that you know how you run the show. And in the end, Q&A. Who is answering which questions? Or do you have the situation where you have one question, the first person answers, the second person comes, yes, I would like to add something as well, and then the third person comes, yeah, but this is a bit different than you actually said before, and then your credibility is again gone. Finally, practice the stuff and energy. Practice. The golden rule I follow for such a pitch is 5 times trained the stuff. I've done it 5 times, I know how it works. People were giving feedback to me of how I have done the stuff. And energy, in the end, it's your voice, your personality that matters. If you're here and like, I would like to present you something, this will not fly. Show energy, show you're here, show this is the coolest product that you developed and that you really believe in this product. And that makes immediately a difference, and people will keep a complete different attention span to your product or solution. And I know in a hackathon this is difficult. You will, I think, submit tomorrow morning your video. The last 15, so the plan will be 2 hours before the submission, you start preparing the video. I'm pretty sure you have this plan somewhere. The reality will be after 1 hour before the submission, you start to think, fuck, we should do it. Sorry to use this word. And 15 minutes before, you're actually really doing it. Make a plan, stick to the plan, use enough time. I personally believe a good pitch is way, way, way stronger to win than a perfect product where every color is the way that it should be. You need to sell it in the end. It's not only the product. So stick to the plan, allocate time, whatever you can already do today in order to prepare the stuff, do it today. That was it from my side. Some inspiration, I think you know that the videos of the last few hackathons are online, the pitches. Go and look at a few of them, that you get some ideas of how they have done it. I don't say this was the truth, what I was telling here, but it was one idea of how to structure your pitch. I hope it was helpful. Happy to take any questions here on the stage or separate. I'm still a few minutes around. And thank you very much for your attention. Have a great afternoon, everybody, and good luck. Yes?
So if we have a hybrid team, and can we be one person here attending and presenting, and the other person hybridly, if it's a developer showing, for example, or doing the Q&A, the technical questions?
Yes, I would do something like that. I think it's a good question of how do you integrate a remote person in that sense. So demo certain QAs, but then be clear with the rules. Don't have the remote person just jumping in somehow, but have rules, who is answering which questions, who is doing which part. I think that's the key there. And in the video, it's not yet relevant, but hopefully afterwards. You're welcome. Any other questions? Yes?
What about the design of the slides? Should it be like very light or more compact? And 2-3 slides more compact, or a lot of slides and very light? Thank you.
No slides, just as a demo, I think would be the optimal solution. If you have slides to explain the stuff, very low number of slides and text low. So images, a few keywords, stuff that people can remember. No overflow of text, they don't look at it. If I look at our team, the way they basically will review the submissions, they don't have time to read through every slide in detail. Key messages, that's the important thing. Any other question? Good. Thank you very much. Good luck.
Hi everyone and welcome. My name is Ciro and I'm with Victor and Alessandro, and we would like to present to you Ascento. Unfortunately, we weren't able to present in person, so there will be no live demo, but we have some cool videos to show to you. So what is Ascento? Ascento, as you have seen in the video, is a self-balancing robot that combines the speed of wheels and the versatility of legs. It started as a student project at the HackZurich. It lasted 9 months, and our main goal was to rethink how robots move in indoor environments. One of the main challenges in indoor environments are stairs, and amongst all possible ways of climbing a stair, we decided to go for the most challenging one, and well, maybe also the most elegant one, which is jumping. Now we are 5 robotics engineers and plan to go further with this type of system. And this is what Alessandro will talk about at the end of the presentation. I'm going to present to you the main features of Ascento and what has been done during this student project. Victor will talk about the improved version and the research that has been going on since the end of the project. And Alessandro will talk about the future outlook. So, as stated before, Ascento has both wheels and legs, which make it very fast on flat terrain, but as well can drive on uneven terrain and overcome small obstacles, such as steps, by jumping. So it also can be extended to outdoor environments. All structural parts are 3D printed, allowing for fast prototyping. First, next slide, please. We are able to produce and assemble the entire robot in less than 1 week. We were also able to iterate 3 times in less than 9 months during this student project. All parts are also topology optimized, which is why you can see that the shapes are, they have this organic and interesting looking shape. This allowed us to reduce overall mass, resulting in a lightweight and compact system. The entire system weighs only 10 kilograms. Now for driving, we use 2 direct drive motors and a compact wheel design, which has been custom made. Next slide, please. As you can see, everything is very compact. The wheel assembly has been custom made for us. The leg geometry itself is also optimized, so we can have a perfectly straight jump. This also makes it a little bit easier for control. We can more or less decouple the jumping from the stabilizing action. And for jumping and controlling each leg separately, we use 2 very strong motors, which are series elastic actuators. So to keep the robot in upright position, we have implemented a robust stabilizing controller based on a linear quadratic regulator. And we also have implemented a separate jumping controller to jump and a fall recovery controller. Many people ask what happens if such a system falls down, and it can stand up on its own from every position it falls. We also added intuitive steering to make it easier to steer. Now, of course, you don't want to test the system directly. Your freshly written code directly on the real system to avoid any injury or damage. So we set up a simulation environment, and once we have tested everything in simulation, we patch everything to the real system, and you can see now that it drives, it jumps up a little step. This looks easy to do, but it's very difficult to do. And Ascento also has many sensors and cameras. The sensors are mainly used to measure the distance to obstacles and detect them, and sense its orientation to stabilize. Using different cameras, it can map its surroundings and track its location. It can also create a 3D map, as you can see, to, for example, parameterize a step and calculate the torque needed for the jump. Using these sensors and cameras, Ascento is also able to do simultaneous localization mapping and drive completely autonomously. We have the next video, which summarizes what we have achieved after these 9 exhausting months. If you could please show the video.
Hello and welcome to the second part of this presentation. Thank you, Ciro, for this great start. So after the student project, the robot worked well, but we still saw a lot of unused potential. Can you hear me? Hello? Can maybe somebody write in the chat? Ah, okay, great. So let's get back to the presentation. There was some connection issue. So after the student project, the robot worked well, but we still saw a lot of unused potential. We still had a hunger to further improve its capabilities and to add more features. Our main goal for this second year was to gear our project a bit more towards research and to bring the robot outside to the real world in order to make it terrain capable. Let's start by reviewing the current project standings. The robot could stabilize robustly, but it always moved both legs jointly. The problem was that balancing control and leg control was separated, which we are going to tackle now. Well, to truly be terrain capable, we need to be able to move the legs individually and to react accordingly with our balancing control. Like for this obstacle here. The robot needs to extend the other leg while maintaining balance with the wheel, which still has ground contact. To solve this problem, we had to understand how the robot moves. Until now, our controller assumed an inverted pendulum with a variable extension length. But to really understand how to move its legs, we had to understand the complex leg geometry of the Ascento robot in more detail. Unlike most comparable systems, Ascento has a very special motor layout. For each leg, Ascento has a wheel motor, but only one hip motor. Comparable systems have typically another motor in their knees, allowing a leg motion in 2 degrees of freedom. But how can Ascento bend its knees with only one motor? The secret is the special leg geometry of Ascento. It consists of 4 bars which are assembled in a loop with one motor to move the leg. Such a geometry rate. To physically model such a linkage is not an easy trivial problem and posed a huge challenge for us in our second year. But when we got around that, we could finally model it and give it to our controller. Our controller works as follows. We start with the user input. For example, a commanded robot hide or a driving command from a remote control. Then the controller solves a hierarchical feedback optimization problem, which outputs all the motor torques for the robot. So the 4 motor torques. used. So let's look at these tasks a bit more closely. To assess the system dynamics, we created our custom model in MATLAB, so a rigid body simulation. The base height can now be controlled by the user and allows for much more dynamic maneuvers. The base roll allows us to lean into curves, as we will see later. The balancing is now also a lot more robust and even works with one wheel on top of a step. The heading direction control works also on inclined planes, so the robot actively adjusts here shown in the right video. And in the end, we minimize the activation torques used, so it also minimizes the energy used, which increases our battery lifetime. So let's validate these control approaches with some experiments. First, we compare the impact robustness of the new controller is significantly more robust. This is because the new controller looks at the system dynamics around the current equilibrium point and has the entire system dynamics to work. How we adapt to different ground heights. To quantify that, we show this experiment with an unknown disturbance. So the robot does not see what's coming for him. He's just reacting with an active suspension. The third experiment is for curve driving. Here, the robot leans into the curve to bring its tipping point to the middle of the two wheels. That way, the robot is really stable when curve driving, like a motorcyclist. With all these features, we can now tackle a range of different scenarios, disturbances, and obstacles. Indoor as well as outdoor, these challenges now are easy for the robot. Here, the robot is still teleoperated by a remote controller, but this could be, for example, extended by a suitable autonomy kit, for example, a navigation system which drives the robot around autonomously. Also outside, the robot performs really well over grass slopes or over uneven terrain in general. We now composed a second video which shows all of our features we had developed during this and the last year in one total video. Thank you for your attention. And I'm handing over to Alessandro later.
Hi, can you hear me? Good, perfect. So now I will talk about the next step, or how we will now continue with the project Ascento. So in a first step, it was more of finding out how we can move, or what would be a cool mobile robot. In the next step, what Victor now told us, we focused more on the technology part. So what do we need to improve for it to become a project in the future? And what I'll be talking now is how do we see our future and what our next steps are. So maybe to just have a very short recap, I listed here all the prototypes that we have built. So in the beginning, we had to improve our hardware a lot in the first year. And then now for the last 2 years, we heavily worked on software, making our robot really move such that it is an ideal agent for mobile robotics. Now, the big question is, maybe before that, we now are in heavy development for the next prototype, which will then also be used for industrial use cases. But this we will probably only show within the end of this year. So a big question is, why is Ascento a cool robot, and why we believe it is an ideal use case for mobile robotics? So if you have a look at the current robotic landscape, we can see that there are very cool systems now developed for aerial robots, and also very cool systems for ground robots. And if you have all these systems, one can briefly separate them between air and ground robots. Whilst air robots are very good if you want to inspect large environments or have tasks that involve that, whereas ground robots are much more suitable when you need to do close inspection, when you need to carry heavier sensors, but they are a bit limited due to their range. So obviously, Ascento is a ground robot. And if we have a look at all the possible ground robots that currently exist, one can plot them on this two-dimensional axis, where on the y-axis we have price. So very low price is very desirable. That's why we put it on top. High price is not so desirable. And movement capabilities on X. And what we see here is that obviously the four-wheel simple robots are very cheap. But as soon as you have a little curb or step, you are limited. And on the other extreme, you have the human being, us, very versatile. We can do many, many things, but our costs are very high. And also, we don't want to put humans at risk all the time. Then you have also the legged system, which try to mimic what humans can do. And you have also tracked system that are slightly better when it comes to some obstacles, but also get caught up a lot. And so what we believe Ascento is, it's the combination of both worlds. We get high speed from the wheel systems because we also only drive with wheels. The whole system is very simple, similar to wheel systems. The whole robot just consists of links and some motors, and there are no special parts needed. It can all be easily manufactured at a very low cost. We have also payload capabilities because all our body is balanced out with an intricate spring system, which then not transforms to more energy costs like a leg system or humans. We need a lot more energy when we carry heavy loads. For Ascento, this is not the case. We have a very special spring system for that. And then on the other side, we also benefit from the legs. Like we have a very good terrain capability thanks to these legs, and we can also change our configuration. We can be very big to see a lot, and we can also become smaller if you need to fit through tight spaces. And with that said, we believe that Ascento is somewhere here. So we believe we can be a lot better than all the wheel system when it comes to movement. We're definitely not as good as legged system for all of these edge cases. But for most applications, you don't need superhuman movement capabilities. You just need to be able to go where humans can go. And this is something that we believe with Ascento we can truly manage. That's why, after having these thoughts and having a lot of interviews with potential use cases, we said, okay, so what is our business case? How do we see ourselves in the future? And we have a lot of attention from partners in the industrial inspection area. And there they have two main pain points. One is their routines are very laborious, take a lot of time, but need to be done very precisely. And the other thing is they sometimes need to do inspections which are a bit dangerous for humans. And there they want to avoid the human factor. So they don't want humans to go close to machinery, but they would like to have an agent that can close it there, and then the human can just analyze it. And if there is a problem, you can shut down the machines, and then the human can go and fix it. And this industry needs three key features, which is a very robust design. This is in every industry, you want robust design, otherwise it's not really needed. Then they want to have fully autonomous systems where you don't really need a human in the loop. And they would like to add custom sensors. We believe we can achieve all these goals with Ascento. Currently, we're mainly focusing on the design and the locomotion principles, but we are heavily on track to also manage the other things for next year. And I can show a short plan, what we're up to now. So we have a concept prototype, we have a committed team, we have funded research as well. And our goal is with first industry partners to then do first testing, release the MVP, and then found a company next year. With that said, I'm done with the presentation. In case you have any questions, feel free to reach out to us on any of these channels. And yeah, unfortunately, we wanted to do a short live demo, so I just have a quick video which shows some features of Ascento, which you can have a look. But yeah, other than that, if you have any questions, please reach out to us via these links or via Slack. Thank you.
know someone is has credit, and how do you actually like calculate the initial credit that we're going to build this platform on top of? So these are really things we have been solving in these 2 days. Yeah.
Okay. And so how far are you?
I'm sorry, your voice.
How far are you? How far are you with coding the solution? I mean, will you manage until the time?
Well, we're definitely trying, and we have our prototype, and we have a social media that is presentable, I guess. But these are just the challenges that, for example, the algorithm that we're going to use is not completely finished, and I'm sure we're definitely not gonna get everything done in the hours left, but I don't know. I hope we can
it's
have
a starting
something
point. It's a starting
yeah,
point.
it is. It is.
Exactly. Wow. Okay. Thank you so much, Hoda.
Thank you
for pitching that, and good luck.
Thank you.
I think I'm gonna just add everyone on the stream right now for the picture, so the people that are done pitching can actually leave. So let me add Jonas again. We have Federica here, and I think we have here someone else, but I don't know. Hello, stream, with the name stream, but there's no picture. So maybe I'm just gonna remove someone else's devices. Okay, well, we're just gonna take a group picture of us together, okay? And maybe actually what we wanted to do is the waves that they did. Everyone did that together yesterday.
Okay.
So Joda, you and I start, and then it's Federica and Jonas. Okay. So we join the group picture of yesterday. Okay. Joda, 1, 2, 3. Okay.
And now, okay.
Okay, let's redo it. I'm gonna start and Hoda, then Jonas, and then Federica.
Okay.
1, 2, 3. Okay. Anyway, a connecting exercise. So I'm going to go on with Federica. Thank you so much, Hoda, and Jonas. If you want to stay on, you can. But otherwise, we're gonna go over to you. Where are you joining us?
So I'm from Basel now. Yeah. Oh, so now it's only 2 of us.
Yes.
Yeah. I'm from Basel, so I'm connecting remotely from Basel. Basel?
Yes.
Here in Switzerland. Okay. Yeah.
Yes.
But I have Italian origin, so I'm a bit of mix. Okay, so
very nice.
actually after Jonas' presentation, I think the Jonas presentation was great because he already had like the video, but I have only the pitch. So I will do only the
okay. That's okay.
Okay.
That's not only the pitch. That's actually a pitch. That's very good.
Yeah.
The floor is all yours.
Yeah, actually, because a lot it's coming from the pitch. It takes the attention of the group and of the company. So it's big. Please give me your advice, okay?
Okay.
Okay.
Okay. Okay.
So okay, so I will start. Sorry.
Do you need to share a screen?
No. I was trying, but no. It's okay like that. It's okay like that.
Okay.
So I wanted to take the document I have in order to give you all the information. So what we want to do is to gamify diabetes-related routines, helping to create healthy habits. So how do we do that? How do we reach that? So thanks to Diago. Diago, it's a name of a spirit animal that will set fun and motivational goals to the patients. Diago will help the patient to be informed on the disease, will push them to do exercise and to collect points to reach the highest level of health. Diago will have 6 level of mood expressions that the patient need to pay attention at, with the purpose to keep the spirit of the animal happy. There is also the purpose of alert the patient when something's going wrong. So there are notification that will remember him to take medicines. Also notification to family contact when in case to introduce them in the game when there is an alert situation. So this is our goal. What's your feedback?
Okay, that sounds very good. And you know what I was thinking about when I heard that? I don't know if you guys remember, but Tamagotchi. You remember that Tamagotchi?
It's that. Yeah, we took example from that. Yes, that's correct.
Really? Okay.
Yeah.
So, but here it's just the other way around. With the Tamagotchi, you as a human being had to take care of your Tamagotchi, and you had to feed it, and you had to, and here it's your animal, Diago.
Yeah.
That will take care of us.
Yeah, actually, we still need to think about the slogan. The slogan could be like, "Take care of the spirit animal, how you take care, I don't know, of yourself." But we still need to think about it, and will be like the last really sentence of the pitch, something like that. What do you think?
Okay. No, I mean that's something. I mean nowadays collect money so much data on our body, like oxygen. I think the new Apple Watch is gonna be able to check your, and then you could, okay, I see that. Do you why did you come up with this idea? Like,
so because
that
the
inspired
purpose,
you?
So the purpose is to inform and to make a patient in emergency country follow, the pathway to be healthy, to be healthy in in this kind of disease. So they have this disease that is a diabetic disease, and most of them do not follow like food instructions, exercise, do not follow the little rules that you need to follow to stay healthy. But also also in the emerging countries, it's really necessary maybe to just do something very simple with a lot of images instead maybe of a lot of words. So that's why we want to do something like that.
So it's an app, I guess. Right? Would it be an app?
It's going to be an app and gamified app. So it's a gamification purpose.
And how does it know that you need some family connection? Do you put in there if meeting a friend? Are you tracking it, or
actually it's more like to motivate them to follow daily all the exercise or diet instructions, because after 3 days that you do not follow those rules or those instructions, your family member will be contacting, say, okay, there is an alert here in the situation. So the family maybe will contact you and say, hey, we know that you are not following the rules, so pay attention, something like that.
So if you do follow the rule, you can maybe you check it. You say, yes, done.
That's correct. Yes, and you will have also a sort of how can I say, how much are you following? So a sort of percentage. How can I say, image or something like that will say, will tell you, okay, so you are following like the rules, the activities, etc. at the 60% of your daily need or something like that. Or also, yes, you're doing great. You are following most. You are over the 60% of other people that are using the app. So you're doing great. Keep doing like this. So also motivational messages during the use of the app.
Okay. Sounds interesting. Well, yeah, I wish you good luck.
Thank
You
you
and your
so
team.
much.
Who is your team?
We are 5 people in the team.
Mm-hmm.
So
They're
we
all
have. So
Basel,
I'm
or?
a no access. There are 2 developers. One that is prototyping, design prototyping. The other one is gamification side. And I'm more like okay, maybe business, because I'm a consultant. So actually, I'm trying to help as much as I can. But of course, they are doing, the operational activities. So I can help, but not so much
Well, we need
this
both.
time.
We need both for something to be
Yes,
successful.
yes, that's correct. That's correct.
Well, very nice. Thank you so much, Federica.
Thank you a lot. Thank you a lot.
And good luck.
Thank you. Thank you so much.
Good luck. Thank
Bye.
you. Have a good evening. Bye-bye.
You too. Bye.
Okay, so we have here, let me see, someone stream, but I don't see anyone. I think the mic is muted. Hello? I'm not sure if this is someone or not. If you can hear me at stream, which is kind of a weird name though. So I guess that's it, I would say. Yeah, looks like that's it for now. Hello. Okay, well, thank you so much for your pitches. That was really interesting. And thank you for watching. I hope that was inspiring as well to see what others are working on. I wish you a good evening. The last few hours of coding and organizing before you submit your ideas. And good luck. We'll see each other online. Bye-bye. Gut. Super.